here is a review of just how to function in the room, Wi-Fi, etc. I will make one plug. We have an app. I think people know this, you guys got a message. Photos have started being posted in the Whova app, so we'd love it if you guys would continue that. And also, at the end of every session in the Whova app, there's a ranking, like a way to rate the session. That helps us just know what kinds of things resonated well, what topics resonated well. So if you get a chance to do that, that's really helpful for us in planning, along with any other comments you want to send to us, because we actually really do look at all of those in our planning stages and how we design the next ones. So what else is on the list?
A couple of other things. So the sessions, we're going to try to keep to time really carefully today because we have a busy morning. The sessions end at noon.
Yes.
And there is
boxed lunches for you to take then, and then you can explore the library or do whatever else you want, but we'll end.
See the butterfly garden, check out the really cool facilities. Reminder for if you weren't here yesterday, for the gentlemen, sorry, the restroom on this floor is not working. But you can go up to the second floor, you just exit out this door, go to the left, and then go up the stairs, apparently.
Yes.
I have not done that myself. I haven't done that myself. And I think that's it pretty much. Wi-Fi, just go on to Austin Public Library, accept the terms just as you normally would. There's no password required.
Books in the lobby are for you guys. I'll remind that. You take anything you want.
Sorry.
That's okay.
I was just going to say, and if you feel inspired to tweet or otherwise post on social, we have a hashtag STEM education. Please feel free to use that.
Right.
And last thing I wanted to say, unless you had other housekeeping?
No.
The last thing I wanted to say is, so yesterday was a really awesome and inspiring day. We hit on a lot of really important themes, I think, for expanding STEM education here and elsewhere. We talked about the importance of asking questions and inviting people in for problem solving. We talked about mentors and different models for that. We talked about creating a diverse workforce. We talked about collaboration a lot. We talked about the experience of inquiry-based learning. So we're going to build on that today. I'm really kind of looking forward to and excited, and we're going to kick it off with a big bang. So I'm going to leave it with you.
Okay. Well, I will not stay up here very much longer because this, as you guys can tell, looks like a very fun stage. Kate Biberdorf works up at UT Austin, but you may know her more as Kate the Chemist. Some of you may have seen her on the Colbert Show. She is going to give us her demo live, and I would recommend stand back. Right, everybody, Kate the Chemist. Yay!
Thank you. All right, good morning, guys. How's everybody doing today? Good, and thank you for not introducing me as Josh's wife, so I appreciate that. For those of you who work in McMillan, my husband's part of this group, and I love being a part of this, so thank you so much for inviting me back. Even after I hit the ceiling last year, I totally thought I'd be banned. So, I'll mention it. I just mention it. We all have growing pains. So thank you guys so much for having me out here. What I'm going to do is give you just kind of like a brief little story about kind of how this all came about and what my mission is, and then we're going to end with some fun demos, because why not? And so, Nikki, it is a black screen in the beginning. There you go. Yeah, it is a black screen. No worries. Yeah, it's good. It's working. Thank you. And so, like she said, my name's Dr. Kate Biberdorf. I'm a chemistry professor at the University of Texas. And 4 years ago, I was sitting in my office, literally just like a block up here, and I received this email from a colleague. And it was like, Kate, I'm going to be on We Are Austin, which is like our local variety show, comes on right after the morning news. And he's like, I'm going to be promoting this upcoming event. Is it possible for you to come out and do like a little science experiment on the show and like help jazz it up? I was like, sure, yeah, I'll try it. And so I go there. And I was basically his prop monkey. I mean, I was standing there. I wasn't even mic'd up. I was handing him gloves. I was handing him goggles. Like, I did nothing. I didn't say anything. And after the segment was over, this woman comes charging into the studio, and she was like, that was awesome. Do you guys do anything for Halloween? And before I could even process the question, I had my palm in the middle of this colleague's chest. I mean, it's a tenured professor, like the blazer with the tweed, like he had it, right? And I just like shoved him out of the way and charged at this woman. I was like, yes, okay, I can make a genie, I can make a ghost, I can make a pumpkin vomit, explode, smoke, I do all these things. And she was like, shh, 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 crazy lady, shh, shh, stop it, stop talking. And so basically what happened is I was allowed to come back and do my very first segment on We Are Austin. After this segment, she came out and said, do you do anything for Thanksgiving? What about Christmas? What about New Year's? And before I knew it, I was having a monthly segment where I was out on We Are Austin doing a demonstration. And so what I had to do is kind of figure out how to present my science. I am used to talking to these beautiful students here for 75 minutes about one topic, and they have to be there. They're forced to be in that classroom. For this, you are voluntarily choosing to watch this show, and if I don't keep your attention, you're going to change the channel, which means they're not going to invite me back there. And so what I started doing was talking about a real-world application right away. Like, what we're going to do today, you're going to see X. And then I started doing the demonstration, and that's when I had to evoke William James's theory of emotional memory. And so I was raised by psychologists, so I kind of believe and so, but this is like the one thing I totally agree with them, is that if you have an emotional response to something, you're more likely to make a memory. And so what I do is I try to have a demonstration, and I get as excited as I possibly can about it, so kind of force you to either love me or hate me, one of the two, I don't care, but one of them, and have that emotional response so that after I do this, I can then shove that chemistry knowledge into your brain for about 20 seconds if it's on TV, but in person it's about 60 seconds. So this led to a number of different opportunities, including this awesome one with Amy Poehler's Smart Girls. And they actually came out to our lab here at UT Austin, did a number of different demonstrations, and I was talking to them, like talking to the producer and getting real-time feedback on my explanations. And it was either really, really good, she would have a big smile, or she'd look at me like, oh my God, you just started speaking in Klingon in the middle of that. Those were her words, her exact words, like Klingon, okay? So I had to, again, change and fine-tune my language. How do you talk to a 7-year-old and a 70-year-old? Because that's their audience, which was really difficult. But the videos were done really well and edited very well. Thank you for Amy to that. And that caught the attention of NBC Nightly News, and then more recently, CNN Great Big Story. But again, a totally different audience. This is news, right? This is 6 p.m. They don't want me going, yay, science! Like, no, that is not what they want. They want the facts, but that's not me. I have a little bit of bubbly personality. You might have noticed that. I'm a bit of an extrovert. And so for me, I had to figure out how I could keep my authentic self, but still present the facts in a news fashion. Well, that led to Pickler and Ben. If you know Kelly Pickler, that was really cool. It was awesome. She's amazing. Which led to Wendy Williams, which more recently led to Stephen Colbert, where he let me do that. And then I got him to do that, which I thought was pretty cool. I mean, you can actually see my face. I am like beyond excited that he was able to breathe fire. I had to go through 3 of his security guards and 3 fire marshals in order to do that, but they still let me do it, so that counts. So then I did what I promised myself I would never do, and I read the comments, right? You're not supposed to do that. And I'm going to be very clear. There was a lot of hate, but haters going to hate. I don't have time for that noise. We're not focusing on it, okay? So what we're going to do today is just focus on the good things. So here were a couple of them. The first one was how cool. I was like, okay, I still have my self-esteem. We're okay, all right. The next one, science, big bold letters. And then I wish I had a teacher like her when I was growing up. My 7-year-old daughter was mesmerized by this video. She could not take her eyes off the screen. Thank you for showing young girls that women can be scientists too. But then this one, this is the one that just like uppercut right in the gut. I finally found a role model for my 10-year-old self. Can I say it again? I finally found a role model for my 10-year-old self. So this one hit me and really resonated with me because you are looking at the girl who grew up with Bill, right? Bill Nye the Science Guy, you know him? Yes? Okay. So I love him, but how cool would it have been for like one female scientist to be on TV, like a Jill Nye the Science gal, just one, like maybe just a girl, but possibly. And so I decided that I had to do something with this platform. It's not just me on Steven, it's not me on Wendy, like it's cool and I'm super excited about it, but there's more to this. And so I tried to do something that would make my 10-year-old self proud. And so I did what I always do, and I listened to Taylor Swift. And I was like, all right, what would Taylor do? And so I'm assuming, I don't know her obviously, but I'm assuming that she is a strong, confident, powerful, talented woman. She's also beautiful, but notice I named that 5th. Okay, that's like her least, everything, just that tangent, that's fine. Okay, so but she has a squad. She has a squad, and she supports her squad. Every interview she does, she talks about her female colleagues. She promotes their music, she shares their stuff, and she is a big, big proponent of their work. And so I decided I'm going to do the same thing. But I'm not really good with the word squad. I stumble saying that, so I decided I'm going to build a STEM army. And the first person I recruited was Livia Eberlin, and she is my age. She's smarter than me, she's prettier than me, she's better than me in every aspect of the world, but I love this woman. And this is why. She figured out how to put a mass spec at the end of a pen so that during surgery, surgeons can figure out in real time if those cells are either cancerous or benign. In real time feedback. It was so cool it was featured on Grey's Anatomy. STEM Army. Number 2, Emily Kay. She recently just won a Teaching Excellence Award, but her research is even better than that. She figured out how to make fertilized eggs glow. So the second the sperm hits the eggs, boom, glow, STEM Army. Shagufta Shabir, her students call her Shabay, enough said. Fatima Fakhreddin was just nominated for the Texas 10, which means she's one of the top 10 professors in Texas. Well, okay, so it's technically the University of Texas, but we think we're the best, so I'm just going to say Fatima's one of the best professors in Texas, and so she's part of my STEM army. But this is just a small subset of the female faculty members. I didn't even mention my male colleagues or my colleagues in engineering or stats or anything else like that, or my graduate students. I have graduate students who now are inviting virtual presentations into our lab. So via a webcam, we're having conversations with people in Macedonia, in Michigan, in LA. We're having these conversations through a webcam. It's awesome. We also have an undergrad who is going out to an all-girls middle school here every single month, because research shows that if you show up once and leave, it's not going to make a difference. But if you show up every single month, you can grab these girls right before they hit puberty and hopefully encourage them to follow their dreams in STEM. So what I'm trying to do is build a STEM army. That was the first thing I decided to do with my platform. Number two, I decided to engage in evidence-based conversations. I no longer can hear someone say, climate change isn't real, and just go, la, 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 la. Like, no, I can't do that anymore. And so my effort, or my strategy, is I use questions, and I always talk with data. I go, okay, why do you believe that? Have you seen this graph? No, you don't like this one? What about this one? No? How about this one? This one really looks to me, climate change is real. And if they still fight with you, take a step back. All right, how is the data collected? Is there something here I'm missing? Is there something wrong? Like, tell me, what don't you like about it? But ask questions. And I need to be very clear. There is no point for condescension here. We cannot be rude. We can't be like, you're an idiot. No, it doesn't work that way. You have to be nice. You have to say, oh, you don't know what quantum mechanics is? Like, come here, let me tell you about it. It's awesome here. Not like, oh, you don't know quantum mechanics? Like, no, we don't do that, okay? So evidence-based conversations. And the last thing, which I think is the most important thing, is you have to talk to kids. You have to talk to kids, as many kids as you can. You need to talk to sick kids. You need to talk to crazy kids. You need to talk to all the kids you possibly can. But unfortunately, I get the same question, like how? How do you engage in that conversation? I'm an extrovert. I love talking to people. I love to talk just in general. You might have noticed that. But my colleagues, not so much. A lot of times they're introverted, so I get the same question, how? How do I engage in the conversation? Fire. Duh. Okay? Every time. Fire. That's my go-to. Unfortunately, the library has banned fire, so today I'm just going to do other things. I will show you what else you can do if you can't have fire. But let me show you really quickly about 3 things. Here's Jax. Jax is an undergrad that I taught how to breathe fire 3 years ago. Now he's going around all across campus doing LGBTQ allyship training to student orgs. And instead of being like, be a good person, he's like blowing fire, doing experiments, and actually teaching people how to be a good ally through science. Here's Nicole. Nicole I taught how to breathe fire 2 years ago. Now she's a graduate student at Rice University. She has her own outreach program. She develops her own demos, her own lecture series. She's talking to kids all the time. I could not be more proud of this woman. Meet Victor. Now, just for the record, you and I know Victor equally well at this point. He's a stranger, and he emailed me that picture. And he works for Teach for America at an inner city school in Arkansas, and he's been following my career and figuring out what he can do. He doesn't have access to a lot of the resources that I do, so he's been creative. He can find anything at Home Depot, so he says. But then he showed me this picture because he finally mastered the fire-breathing dragon, and he wanted to show me what he's doing in his own classroom in Arkansas to try to promote STEM and trying to get kids excited about science. So I think that's just one of the coolest things. But now here's the thing, y'all. I told you I'm building an army, so I need your help. So I would like to recruit you to be part of my STEM army. So if you hear incorrect sentences about science, ask questions, use evidence, talk about data, talk to kids, and then recruit people to be part of the STEM army, which means if you see a good science article, share it. Don't share a blog. Don't you dare share a blog. Okay, I'll talk to you about that later, but a credible source, please share credible sources only. Okay, I think it's time to show you how to actually do some stuff. Are you ready? Okay, now is this a group that wants to do demonstrations, or do they want to just sit there and watch me be crazy? Yes, that's me. Okay, cool. That's all I needed to know. So here's one of the first ones I like to do. I need to point out that I'm obviously in goggles, gloves, and a lab coat. I work for the University of Texas, so it's very important that I reiterate that you must be safe at all times. Okay, now that the boring part's over. What I have here are 2 beakers. And one of the first things I like to do is start with this demonstration, especially if I'm in an elementary school. This one works really well there. And so the first thing we do is we try to, if I can open my bag, we add some food coloring. So I've got blue, yellow, green, or red. What do we want, guys? Blue. It's always blue. It's always blue. You can vouch for that. I go through more blue food coloring than anything else. And of course, that's a hard one to buy in bulk because nobody wants blue cookies. I don't know why that is, though. Okay, so we go from a heterogeneous mixture to a homogeneous mixture just by swooshing. And then we're going to come over here and set up our other beaker. And so now if I had a kid here, I would obviously have them wear cryogenic gloves because it's not safe to grab dry ice. But we all know dry ice is solid carbon dioxide, and as long as you don't hold it for too long, you're not going to burn your hands. And so this is the very first demonstration I like to do, just to kind of get the conversation started. I pick this up and dump it in here. Ooh. Ah. Ooh. I know it's 8 a.m., but you can join me. Okay, here we go. And so what I love about this demonstration is right away it's going to evoke some kind of response. Either you're going to be like, it is too early for this, or you're like, whoa, what is happening there? And so what we see is the sublimation of carbon dioxide. It starts as a solid, turns into a gas. And this is a really easy way to start talking about a physical change. Now, if I'm talking to a high school student, I'm going to push them. What kind of physical change? Is it sublimation? Is it condensation? And then the really smart kids, I'm going to take it an extra level. What is the energy doing here? And it's clearly an endothermic process. So that dry ice needs to take the energy from somewhere and then go through the transition into the gas. Next one. So then you take it up a notch. So the first thing I want to ask is, what are these called? Do we know? Graduated cylinders. Tell me you all knew that. You all knew that. Yes, there we go. Nikki knew it. She was yelling from the back. Okay, so what I have here are graduated cylinders. I filled them up with our Austin tap water, which is naturally basic because it runs over limestone and absorbs our minerals. But I've spiked it with something called universal indicator. And the universal indicator is going to let us know if something's going on inside of our reaction vessel. Now I'm going to add some dry ice. We're just going to kind of slowly watch that same physical change we saw before, where we see the sublimation, where our solid dry ice is going to turn slowly into gaseous carbon dioxide. And then we see the color change in the inside. So we went from the purple, which was basic, pH greater than 7, to the green, which is neutral, which is about pH of 7, to yellow at the end. Yeah, I love this one. Isn't it awesome? Yes. Okay, so now, this one is acidic, so it's a pH less than 7. So we went from purple to green to yellow. And so we actually saw a chemical change in addition to the physical change that's still happening. Did you like that one? Yes, I love these. Oh, thank you! Perfect. All right, so now we're going to take it up a notch. And I'm going to try to do this. The water here is like way more basic than I was expecting. I didn't even spike this one. For those of you who are familiar with phenolphthalein, this was straight up. I didn't spike it at all with any base. So I'm not sure if this is actually going to work, but I'm actually really excited to try it. So now, what we did here in these last two is we added dry ice, or carbon dioxide, to our solution through dry ice. Now I'm going to try to add carbon dioxide using my breath, so we'll see if this works. Oh, it's working. Ooh, ah. So this one is called a Valentine's Wish, and it's a really fun one to do after that without telling them what you're doing. Like, why am I exhaling? Well, you exhale carbon dioxide. Now here's just a question. What % do you exhale for carbon dioxide? Anybody know? 4%. 4. It's a common misconception because we're taught that you just exhale carbon dioxide, right? I mean, we literally teach you that in 5th grade. However, if that was the case, CPR wouldn't work, right? Remember that? There we go. Okay, good. That's just a pet peeve of mine. I had to throw it in there. All right, so that's a Valentine's Wish. I always do that on Valentine's Day, and my goal is to pick 2 people out of my class that I think are into each other, and I make them do it at the same time. However, sorry, you guys don't volunteer. That's coming up. But 2 years ago, I actually invited someone who was married to someone else up, and so I don't really try to do that one anymore because that was an accident. Okay, moving on. So now I want to stay with the color changes and do something that I think is a little bit more fun, but I'm not going to use carbon dioxide and I'm not going to use dry ice. So this is something, well, I actually don't want to tell you what it is in case you know already. So this is the 4 molar hydrogen peroxide. Okay, we're going to add this slowly. All 3 of these solutions that I'm adding are clear and colorless. They basically look like water. Now this second solution has 2 things in it. It's potassium iodate and a little bit of sulfuric acid. Again, looks like water. And the third one has 3 things in it. Malonic acid, starch, and a little bit of manganese sulfate. Ooh, how did I do that? What? Oh my goodness, isn't that crazy? 3 things that look like water. We added them together and they turned to that really cool amber solution. And then all of a sudden, magically, somehow, oh come on, there we go. Come on! Thank you. So this is called the oscillating cloud shock or the Briggs-Rascher reaction. And so what happens is it very slowly goes from the clear colors, and then it goes to the amber color, and then to the blue. Now, because of my last question, I feel like we have a variety of STEM backgrounds in here, so I'm just going to go with like a kind of a simple explanation for this one. But if you want to know more, please come talk to me afterwards. But basically what we said, there's 5 things in there, and that's going to pop off, Chris. We can, yeah, hold on. So there's 5 things in there, and so what happens is we basically have A plus B, which react to form C. As soon as C forms, D is sitting here in the flask, so like, whoa, 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 I like that. And so D reacts with C to form B. Well, B reacts with A to form C, which reacts with D to form B, which and so we end up having 2 competing mechanisms that happen over and over, back to back. This lasts for about 10 minutes, and then we slowly form a purple color, and we release something that we don't want to breathe, so Chris is going to be watching this to quench it in about 3 minutes, okay? All right, so now, back to a cryogenic. This is not a cryogenic. This is a cryogenic. Got our liquid nitrogen. Oh, I love this stuff. Isn't it amazing? So liquid nitrogen is very cold. It's negative 194 Celsius or 77 Kelvin. Oh, that feels good. Okay, what's room temperature in Celsius? 25, yes, right there. Okay, so now what we're going to do is take this beautiful octopus, and we're going to see what happens. And so now usually I like to fill the head of this octopus with helium, but there were 2 rules today. No fire, no helium. So instead this is boring old air. It still works though. Okay, so for the sake of time, I'm going to pull this out here. And so I'm going to show you what I do with my students, which is an example of a physical change. So it started off as this beautiful, wonderful octopus. And then I put it into liquid nitrogen, where I can show them an example of Charles' law, where we see as the temperature goes down, the volume of the gas is going to go down. And then as I bring it out of the liquid nitrogen, as the temperature warms back up to room temperature here, we see that our volume comes right back up. Now the cool thing is, though, if this is filled with helium, as soon as I let go, it literally starts to fly away. So the kids are like, what's going on? So we're going to pretend. Fly. Wow, that was so cool. Yay! Oh, hold on a second. Here, hold on just really quickly. Just to be dramatic. And because I love Susan. There you go. There you go. Come on. Like, you look so cool. Your haircut looks awesome. I don't know. You just need it. Okay, so, but that's another example of a physical change. And then we can start talking about density. Like, why does the helium float? Or why would the air sink, right? We can have all these conversations together. And we're going to do a number of different stations afterwards while I clean up. We have 4 things over here, so this is actually one of them. So I'm going to allow you guys to play with smaller balloons and some liquid nitrogen. This is another one I have over there for you. And what I'm going to do is use a beaker and 2% calcium chloride. This is one you guys can actually do at home. One of the things that I firmly believe in is doing demonstrations where at least one thing you can actually do at your house with your kids, with your sister, with your grandma, whatever, okay? 2% calcium chloride, 2% sodium alginate. If you buy these things on Amazon, make sure you get food grade so you can actually eat these. Now let me show you why. Let's do some blue, some orange, a little bit of this other one too. Oh, we're leaking. That's all right. The blue one's working perfectly. Look at that, guys. That's how you make gummy worms. Ooh. Who wants to eat it? No. You don't want to eat it. Sodium alginate comes from algae. It's extracted from brown seaweed, and so it doesn't really taste that great, but for me, it's more of the texture. It's that like gooey texture, and this is considered to be a gel. So when the 2 things come in, we have an ion exchange, so the sodium alginate then releases the sodium and grabs the calcium, and so you end up creating this really beautiful long polymer, which ends up being like a gel because it's a liquid trapped inside of a liquid. So have you ever had a gusher before? That's what it would taste like. So you bite down in it, and then that like nasty calcium chloride comes out. So for kids, I have the kids eat it all the time, and they love it, but for me, it's just like too gross. I cannot do that again, so I would not do that to you, kind lady. Now, here's the next one. This is where we're taking it up a notch, and I'm going to start talking about catalysis. So here, I have 35% hydrogen peroxide, H2O2, and I'm going to try to break it down with a catalyst. So this is called Genie in a bottle, and this catalyst is my manganese trioxide. Now, because we're almost in October, I want to pretend that this is a ghost, okay? Let's see. I don't want it to be too big, Susan. I'm like terrified of hitting your ceiling. Oh, we got this. Okay, we're just give it a second. It's gonna go. So what we're slowly seeing is our catalyst is coming in there. Oh, there it goes. Yeah, I love this one. Look at that. Oh my God, I love it. Okay, yeah, let's give it up for this one. And so this one is called Genie in a bottle, and so what we have is hydrogen peroxide, H2O2, and we've decomposed it with our manganese trioxide. So if you can see, if you're in the front, you can actually see the water right here that is condensing on the inside of our vessel, and we just released oxygen gas. Now if I had a big source of fuel near here, I could actually light that gas on fire and we would have a big explosion, but again, no fire in the library. All right, so I'm going to move this one just because it's hot. And now can I have my volunteers jump up for no reason at all. I just want you to like put this tarp out. I think it's more aesthetically pleasing, I think, maybe. No reason. There we go, guys. Thank you. And why not just go ahead and set the other one up for me, please? Yeah. All right, so now, and then you don't want to be there. Yeah, there we go. Okay. So now, this right here is a bigger Erlenmeyer flask, and so we have two competing catalysts. So that last one was the manganese trioxide. This one is potassium iodide. Now, I personally love that last one, the one we just did. It's my favorite. I think it's just so cool. You can never, I don't know, I just think it's awesome. But all of my colleagues disagree with me because they think this one's better, but they're wrong. So we're going to vote, and you're going to have to tell me which one you think is better. So this is hydrogen peroxide. H2O2 again, 35%, same thing. I'm just using a little bit more of it. Need food calling. I also have Dawn dish soap here. There is no reason why we use Dawn dish soap, but they save penguins and they're my favorite animals, so we always support Dawn. And then we need some food coloring. We have blue, yellow, green, or red. What do we want, guys? Green. That's good. So green and blue. We're going to have some kind of really beautiful turquoisey type thing. That's good. And again, we're going to look for a heterogeneous mixture. Chris, can I have you get that for me, please? Ooh, that is beautiful. Good call on the green. I love that. You can use the same type of chemistry to make vomit out of a pumpkin. This would be good vomit. We got to remember that. Okay, so now, actually, can you move my doer out of here just again for no reason? Here we go. Potassium iodide into hydrogen peroxide. Let's see what happens here. Oh, beautiful. That's a good one. And I didn't hit your ceiling. That was the bad one last year, so give it up for Yay Elephant Juices! Look at that! Oh, I love it. Science before 9 a.m., man. That's how you do it. I love this. Okay, this is elephant's toothpaste, so we're releasing oxygen gas. We trapped it inside of the dish bubble, so it's going to continue to release and be trapped inside. Again, you could light this on fire if you had a good source of fuel sitting around here. Oh my gosh, look at that one. All right, y'all.
I want you to know security.
Hi. Hello. Turn around for the next one, because it's grand finale time. Excuse me, you guys don't want to be there. All right, and let me make sure, Chris, can you help me really quickly? This tarp, I just want a little bit more overlap, please, right here in the center, if you pull that. All right, so what we're going to do here is a small, Mickey, small, very small. It's not small. Okay, so what we have here is I have a bucket over there in the green in just a second after Chris is done. Can we please give it up for my amazing volunteers who got here at 7 a.m. on a Friday? That's perfect, thank you. All right, so now, what we've got here is our big bucket. Can you prep that for me? And what I'm going to do is add about 5 liters of liquid nitrogen-ish. Let's do 10. Okay, 5. And then what I'm going to do is add a little bit of hot water. Now, when I'm in a safe space where there's not beautiful, well-dressed women right in front of me, just put that behind there just in case. Okay. I usually do this, and I try to throw my hot water in so I can get about 3 stories high. Now, like I said before, not allowed in this building, so we're going to do like a bunch of little baby ones. Are you good, Chris? Okay, here we go. Guys, thank you so much for coming out here. Please, please, please join my STEM army, share good science, talk to kids, and use evidence-based conversations. Here we go. 3, 2, 1. Yay! Where is it? Let's do it again. Oh, that one was cool. Thank you guys so much. Hook 'em horns! Did I get you? Did I get you wet? Okay, good. Thank you guys. Can I please give it up for Nikki? She coordinated
everything for me. I owe everything to you. Yay, Nikki! All right. So what we're going to do is while we clean up and get all these wonderful things off the stage, we're going to invite you to join us over here for a couple stations. I believe Nikki has a plan on how we're going to do that, so we're going to dismiss by group. But we have 4 different things over there. Please help yourself to them. My students are super excited to do some hands-on science, so please go talk to them. Ask them questions. Thank you, guys. I really appreciate it. Thank you.
Nikki, what's the... Sorry. Nikki?
I'm going to go say hello to Professor.
Okay. Nikki, what's the plan? Okay, so, but there isn't like an order. Okay, my mic is not on.
So guys, this is pretty casual, pretty informal. If you want to play with the science toys that Dr. Biberdorf has set out, feel free to join. We have facilitators, so at your leisure. Thank you.
not you. No, not you.
Watch this coffee go away.
Okay, I have two quick housekeeping items, and then I'm going to turn it back over to Mariette. One is we have found a parking ticket, a stray parking ticket that is not validated. So if you are missing yours, I'm going to leave it up front with Donna. She's got it. She's got your parking ticket. And two, a lot of people were asking us for information on Kate Biberdorf. I have put both her Kate the Chemist about her website link in the community part of the Whova app, as well as how to get in touch with Fun with Chemistry and have her come to your place. So if you need any more information, it's in the app. Mariette?
Super, thanks a bunch, Susan. So I am just so excited about the conversation we're about to have, and I promise I'll let you all have a chance to ask questions as well, but I'd like to welcome to the stage Dr. Sylvester James Gates. He prefers Jim. Thank you for joining. Yay! Thank you. It's such a pleasure. Please, we're gonna sit. And we've only had, I don't know, in total maybe, what could it be, 17 minutes of conversation between us?
At most.
So I'm super excited. Does it seem to be working? Give it a try.
Can you hear me? No. Yes, it's working?
Yeah, now I hear it.
I always like to say, can you hear me now?
Can you hear me now? Yeah, sounds good. But when we first were chatting, one thing Jim said to me is I'm just a simple country theoretical physicist, which charmed me immediately. And so the first thing I would love you to do, Jim, if you don't mind, is talk a bit about you.
Okay.
And I remember you had a couple of slides. And
We
I
have
found
some
this,
images, yes.
This for you.
Okay, very good.
And there's a screen there and
Okay,
there, so you
okay.
can see.
Well, first of all, good morning.
Yay.
It's my great pleasure to be here. I have to tell you that my job is to put you to sleep. You were a little bit too excited by that last presentation. I was watching people's energy level go up and up and up. It's like you had a super cup of coffee in the morning. Well, Kate was great, wasn't she?
Yay.
So as I said, I'm going to try to bring things down a little bit. But I don't want you to go to sleep, so please don't start snoring. So my name is Jim Gates. I am a theoretical physicist, and often people meet me and wonder, how does an African American like you get to do what you do at the age that you came through? And the answer is actually on the screen. These are pictures of my parents. That's my dad, a picture taken in 1962. 27 years in the U.S. Army, so I began my life as an Army brat. And that's not an insult. Those of us who have gone through that life happily own that term brat. So I spent part of my childhood in Canada, St. John's, Newfoundland. And that picture on the other side of the screen is my mother. And my mother, but the curious thing about it is that picture was taken in 1942. And for the longest period of my life, I never even knew that picture existed until quite late, a few years before my father died. And so my father was kind of where I got my analytical side from. His grandfather could neither read nor write, but he could do arithmetic. My mother, on the other hand, was sort of an artist. She crocheted, she fired clay figurines, she did knitting, and, you know, the sort of just artistic things. And so part of my luck is that these are my parents, and they had these two strange set of abilities that came to reside in me, and I've exploited these all of my life. The other thing I think I'll do is, this is why I'm a scientist. This is a movie that came out in 1954. It's a science fiction story, but it's very strange. First of all, the production values are very poor compared to Star Wars and Star Trek, and all these things that you're used to these days, are very poor production values. But at age 4, I saw this movie in Canada, and it was the first time I heard the word science, and it may be the first movie I ever went to. And to me, science was immediately clear to me that science was a doorway to adventure. And as a 4-year-old kid, I wanted to have lots of adventures. And so it's all about inspiration. That's what Kate was giving, was inspiration. I have a friend who is named Paula Apsel. I don't know how many of you recognize the name, but she's the executive director of Nova. And I bet many of you have watched Nova episodes. And a few weeks ago, I was reviewing something, and I found this interesting quote. She said, for the NOVA program, the goal was, A, we have to get the science right. So yes, we have to be factually correct. B, we have to be entertaining. And just as Kate just told you, you know, you've got to get, if you're going to be in a media like that, you got to follow the rules about putting content out there. But she said, most important, we have to be inspirational. So you've got to combine those 3 stools in order to make it work. And that's what this meeting is about. That's what programs like NOVA is about. And all of us have our part to play. And so this was my inspiration, this crazy science fiction movie.
I wrote it down so I can watch it later.
Don't do that. And, Mariette mentioned that I often tell people I'm a simple country theoretical physicist, and that line is sort of a perversion of something that the doctor used to say on Star Trek. If you remember, he was always a simple country doctor. So I'm a simple country theoretical physicist. I love what I do, and I'm having this the time of my life. So mentorship. Let's go there for a while.
Let's talk about mentorship.
Yeah, okay. So as I said, my father turns out to have been my first mentor, even when I didn't realize it. And for those of you who are parents, in case you're not aware, you're mentoring those young people in your household, even if you don't know that you're doing it. So you need to be intentional and conscious about that. Yeah. And so my father was a mentor. He had an innate love of mathematics that not that he tried to make me do it, I watched him. And when I started school, I had trouble in language arts, but arithmetic was trivial as far as I was concerned. So we were just the inverse of everything that most people experience as they go through the early childhood education. So I've had a series of mentors that were just wonderful. Let me go and show you, I want to show you the end of this thing. We're going to move fast through this. Oh, I'll stop here. That's one of my mentors sitting down in the middle of that picture. 1980, first time I met Stephen Hawking. I knew Stephen from that year until the end of his life. That's Murray Gell-Mann and John Schwartz. They're very famous physicists at Caltech. Murray Gell-Mann is Nobel laureate. And from 1980 to 1982, I was a researcher in his group. The other lead professor in that group is maybe someone else you've heard of, a guy named Richard Feynman.
Yeah.
So I actually got a chance to be tutored as a scientist and also as someone who speaks about science directly from one of the masters, Richard Feynman.
That's
and
awesome.
then finally, well, we'll skip that one.
I like that picture. That was a
Okay,
good
we'll
picture.
go back to it.
How old are you there?
So this picture, this was actually my Caltech ID.
I love that picture.
So I used to have what I call the perfect spherical afro.
Yes.
And
beautiful.
that provoked a comment actually from Richard Feynman when I first met him. I was at a table feeling very nervous. A lot of other obviously very smart people there, and I figured, if I say something, they'll figure out I'm an idiot.
Aww.
So the simplest plan is just keep quiet. That way they can't figure it out. And Feynman was sitting probably the distance I am from you, and he looked over around the table and he said, "Mr. Gates." And I said, "Yes, Professor Feynman." He was one of my heroes, a lot of us in physics. And he said, "When I was your age, I wanted to wear my hair just like that." And I had this vision of Feynman in an afro. So my fears of Feynman immediately disappeared. But that's the kind of mentoring that I got as a young person. So it turns out the roles of mentors are just so incredibly important. And I was so fortunate in my life that when the first time I heard the term role model, I couldn't figure out what it meant until I then realized I had so many I hadn't noticed. So we'll stop here and maybe get into the panel discussion.
Yeah, that's super important actually, the role modeling and the mentoring. But you're right. When we first were chatting, we were starting to talk about STEM sort of writ large. And one of the things you mentioned to me was your first trip to China and the impressions that left on you.
Sure. So in 2009, 2009, I got a chance to take my family to Beijing. And I tell all Americans, if you haven't been to China, you need to go. Because it is only by going to China that you will understand what the competition really looks like. You may have all these images in your head that come from our media experiences. I remember when I was a kid, there's a film called Dragon Seed. I don't know if anyone in this room actually knows it. It stars Katharine Hepburn as a Chinese peasant woman. kind of an interesting image, but dragon seed, you can go find it for yourself. But the point is that, you know, we have, as Americans, we have all these images that are media-induced images of what China is. Until you go to China, you have no idea what it is. And when you go and experience a large city like Beijing, it becomes completely clear what China is. So I was walking around Beijing and had this really weird sense of deja vu. But it was my first trip to China, so I knew that it couldn't be a memory that was actually occurring, that it had to be something else. And so the something else I eventually figured out was that I hadn't gotten a sense of a city like that, walking around, since the early 60s in the United States. And what I think I caught was a sense of a people confident in building their future. Because that's what America used to be like when I was a kid. You would walk our great cities, and it was clear that you watch the interactions of people, that everyone thought the future would be brighter, would be better, could be made better. And that's the strange sense that I got in Beijing, walking around the streets. And so that's where they are as a society. So now we have to think about where we are. In thinking about China, I like to make sure Americans understand that my perspective is not a xenophobic position. Americans have always thrived on competition. And so I think of China as our competitor, not our adversary. And we need to be approaching it as this is another competitor. As if you were a Longhorn down in A&T and you had a competitor on the football field. That's not someone who's an enemy, it's a competitor. It's someone you're out to best on a field of competition. And that has got to be our mindset as a country. Because I tell people that if you think of our species history, for most of the last 5,000 years, either China or India were the wealthiest nations on the planet. That only changed with Marco Polo. That's when the West had its rise. And I'm convinced that those Eastern cultures, China in particular, has a cultural memory of being the premier nation on this world's surface. And that's the competition that we're going to be in. And whether we're going to succeed or not depends a whole lot about what happens around STEM education.
I think that's a really vital point. And actually, when we were chatting, I sort of called to mind a couple of things. I was just in China last week. I landed in Beijing, and I was in Shenzhen, which is a relatively small city of 13 million people.
Right.
And we were there for the World Economic Forum's summer Davos meeting, which is focused on research. And of course, in China, but it is not uncommon to see investment in STEM subjects, 20%, research budgets year over year. They've been doing that for quite a while now, and their volume of papers is coming up really quickly. And my first time I was ever in China was about a half a dozen years ago, also for one of these World Economic Forum Summer Davos meetings. The real meeting, if you ever want to look it up, the name of it is Annual Meeting of New Champions, but Summer Davos is the nickname. And I remember going to this, walking through the conference center. There were all these hostess ladies dressed in beautiful pink silk dresses that were directing you everywhere. And you kind of eventually got to, you felt they were there, but it was like almost the walls of the furniture. They were there, but you weren't really paying attention to them necessarily. And then one of them looked at me across the room, recognized me. She looked like she was seeing an old friend, came over to me with a big smile and said, "Scientific American, I read what you do." And it was very clear to me then, as you were saying, people with a purpose, people who feel like they're going to be successful, the ambition was clear. And I think that's something that is really important to us in thinking about how do we want to invest. You also used, in STEM and STEM education, which is absolutely vital, you also used the word competition. And that brings to mind another quick recollection that I'd like to share. When I became a AAAS fellow a few years ago, Rush Holt was speaking, and Rush was a physicist congressman from New Jersey for many years. He's now heading the AAAS, the American Association for the Advancement of Science, and he was talking about competition in the form of Sputnik. and the Sputnik era, and what it kicked off for Americans at the time, the sense of purpose, the sense of we've got to get there. The flip side of so there were many positive aspects of the competition. The flip side of it was he felt that in many ways some people felt left out. If they couldn't be part of STEM, how could they get there? Could you, Jim, could you speak a little bit to that?
Sure.
Okay.
So one of the things I often tell those colleagues who were on our side of the line, because we're all involved in STEM, we think it has something very important to contribute to the future of the country. We're enthusiastic about it. We bubble about it, maybe not as much as Kate. But
she does bubble.
But
yeah.
we do bubble also.
Many bubbles.
Right? We bubble about it. We talk to family and friends and colleagues and students. And one of the things I often warn those of us on our side of the fence is that as we do this, a lot of people talk about STEM instead of STEM, insert the arts. And one of the curious things about that is that's right in my mind. I just came from a meeting at Rensselaer Polytechnic Institute, and the question, I was on a panel with Ellen Ochoa, one of our country's most experienced spacewalkers. She just retired from NASA. There were the president of RPI, a woman by the name of Shirley Jackson, was on the panel.
Yeah, she's awesome.
Yes, she is awesome. A retired Rear Admiral. Oh my goodness, my age is showing.
I'm no help, I'm sorry.
Okay, but the question was, are we going to Mars? Mm-hmm. And my response was, that's not the right question. That's like saying, are we going into the future? The answer is yes, we're going to go to Mars. The question is how long it's going to take to get there. Mm-hmm. And I'm rather more pessimistic than people like Elon Musk, for example. Mm-hmm. However, at the end of the day, we all agreed that when we do this, it will be because of American creativity and innovation. And early in the day, in talking to a group of people, we came to the conclusion that ability to create and be innovative rests on the ability to dream. And that's what the arts inspire. And so we're not disconnected from the arts, and that's something to keep very powerfully in mind, that the creativity that we want to bring to bear by the technical prowess of pursuing STEM disciplines will never be realized fully unless it is coupled to our ability to dream, and that is what the arts foster.
I mean, and dreaming makes me think of how do we inspire others and include them. One of the things you haven't talked about yet is your service on the President's Council for Science and Technology and during President Obama's administration and what happened there. Could you share that with us?
Sure. So I was, in 2009, my life sort of went through some kind of weird transformation. Within 2 weeks, I was invited to serve on the Maryland State Board of Education and also on the U.S. President's Council of Advisors on Science and Technology. It's a group called PCAST. There were about 20 of us on the advisory panel. One name you might recognize is Eric Schmidt, the former CEO of Google, was a member. Craig Mundy, who was the gentleman with number 3 at Microsoft at the time, was on there. Our Harold Varmus, the scientist who first figured out how ordinary genes transform and mutate to become cancerous, was on there, a Nobel laureate. And so there were 20 of us on the council that President Obama had assembled to advise him on issues of science and technology where they cross into the public policy domain. So we weren't there to pretend that we were Sheldon Cooper. However, the work that we did was rather fascinating, and one of the projects I like to tell people about, which you'll never hear about in the media that we performed, was about 7 or 8 years ago. It was projected that we would have to, as a nation, curtail the use of things like this. And the reason was because so many of us were buying these devices and were using the electromagnetic spectrum, because radio waves are basically electromagnetic waves. But there were so many of us doing this that we were going to run out of spectrum, because nature isn't making any more of that stuff. So President Obama actually tasked the council with coming up with a solution. We did. We found that there was alternate technology that would solve the problem. It's called the internet. Because the way the internet, the way you access internet is not the way you access radio. But if you just bring that technology over, and it's a proven technology, 20 years of success and growth and what have you. So it's not like you had to even test the technology out. All you have to do is import it into the use of radio signals. And so we wrote this report, and what we, in the report, was led by a colleague of mine by the name of Mark Gornberg. It turns out Mark and I were freshmen together at MIT back 40 years ago, and I never met him at the time.
Huh.
We lived in the same dorm.
Wow.
But the point was that the report showed a way in which to couple that Native American, what we used to call Yankee ingenuity. It showed a modern version of that, how to get out of this problem of running out of spectrum. And when we first presented reports, AT&T and the big telecom said, oh, that's just a bunch of ivory tower professors. They don't know what they're talking about. We're going to continue to do things the way we've been doing them. Within a year, they had changed their mind. Because when we wrote our report, we also carefully went through some calculations of how many more people could buy these devices. And at the end of the day, they figured out that we were right and it would impact their bottom line. And so that's what a scientific and technical council can do. We can look for out-of-the-box solutions to problems that no corporation is willing to do. And that's why having public support through the government of groups of scientists who are not tied to industries that are incumbent stakeholders, why it's so important to foster that. And I fear that that's not happening right now because there is no PCAST. This is the first time our country has not had a group of scientists directly advising the president in over 20 years. So this is where we're losing out, and that's why I keep hearing China in the back of my mind, because if you look at the Chinese government, it is full of scientists and engineers to a far higher extent than our government.
You remind me of the first time I went to Moscow and somebody came up to me and said, the U.S. has been very successful. You must have lots of scientists in your government. And I had a hard time explaining that, yeah. So let's talk about K through 12 reports that you also did, because that's really the crux of it for us here.
Yes, that's this crowd's meat and potatoes, I think. So the council wrote basically 40 reports in the 8 years that it existed. And of those reports, 4 of them were directly related to STEM education. And on those 4 reports, I was always one of the lead authors. That was one of my portfolios that I carried on the council, was STEM education. Our first report was directed to K through 12. It was entitled Prepare and Inspire. And this report actually laid out the case for how we as a nation could invest in our K through 12 STEM educators. Because in fact, we haven't, as a country, done very good by them. So one of the things that came out of that report was a suggestion of 100K STEM teachers in 10 years. This has now been picked up by the Carnegie Foundation. I see at least one person shaking their heads. At least one person in the room knows about this effort. But again, this shows how government at its best interacts with philanthropic and corporate interests. So my previous example was how to help the telecoms. Here we're talking about how to help the school education system. The United States government invests only about 5% of the cost that it takes to run our education system. Only 5%. Now I know people are astounded by it because they hear about Department of Education, this and that and the other, No Child Left Behind. It's 5% of the money that supports our 14,000 school districts. 5%. Now they do have some rulemaking authority, but it's only 5% investment. And so one of the things that when you, at the federal level, when you start talking about leveraging and setting models in place for education, you're aware of the very limited number of levers. And so what you want to do is actually build public-private partnerships or public-public partnerships. So it's not that the federal government can make these things happen, because in fact it can't. And this in fact is one of the confusions that generally American citizens have about our government. During World War II and coming out of the war, it is true that our government had enormous power to shape this society. That power no longer resides with the government. I can guarantee you that. It now resides with our large corporations. It's shared with our large corporations. And in some sense, you might say they have actually probably taken the predominant role. For example, in funding research, they are the leaders. It's not the government anymore. So although you might hear things about our government, if you go and actually do a little research, because you're all STEM-based, evidence-based people, go do some research on these things, and you'll find out that these big messages that you hear do not correspond to the reality. So 10K and 12, but one of the things which I'm most proud of, because I had a direct role in this, I often speak to teachers and education groups like I'm here today, and this was true even while I was on the council. And on one occasion of speaking to teachers, there's a program called the Presidential Award for Excellence in Math and Science Teaching. Because if you take those letters together, I call those the Pampsters. But I was speaking to the Pampsters, and after the meeting, after my presentation, a group of people, much like yourselves, all teachers, came up and said, you know, we love the fact that the federal government is willing to recognize our efforts, because often for teachers it feels like you're the only one. It's like you're out in the wilderness and there's no one else like you out there trying to save the country. And so to be drawn together in a cohesive group and recognized by the President of the United States, by the Secretary of Education, by members of Congress, that's a big deal for these teachers, and they really appreciated that. But they also said, however, we want to do more for this country. It's nice for us to come here and spend a week in Washington, but we would like to go back and have an impact on our individual school systems. And so out of that conversation that I had with the teachers, when we finished our report entitled Prepare and Inspire, I specifically drove the issue of whether we could have what has evolved into the STEM Master Teacher Corps, where the government is making effort to make direct investment for teachers in K through 12 who teach STEM subjects. So that's another example where you can see that you can make an investment, you can't make people do things.
I think I want to give the audience a chance to ask you some questions very shortly, so this is my warning for you to get ready. But before we do that, Jim, I wonder if you could talk about, if you're thinking about education, what's happened since your reports and the impact they've had, and now looking ahead in our current situation, what should we all be focusing on next, and what do you see ahead? So
let me start with the impacts portion first. So as I mentioned, the K through 12 report was only the first in an arc of reports. The next report was called Engage to Excel, which is on the first 2 years of post-secondary education and what the government might do to foster the spread of best practices there. These two reports together have had an amazing impact on the country. In fact, when we wrote these reports, we were very much aware of the political situation in the country, where we have a Congress that was totally opposed to anything that came out of the administration. And so whatever we recommended, it could not be a call for additional appropriations from our Congress, because it would be dead on arrival. Therefore, we concentrate our efforts on things that the administration, the Department of Education could do with partnering with local educational authorities, LEAs as they're called. And so that was our mode of operation. And so the report came out in 2012, so in the last 6 years, I've had a chance to actually travel around the country and talk to people in different education districts and what have you. And it's been amazing to me that many of the things that we sort of put out as suggestions, people have taken up as their own causes and are making at the local level, calling for the kinds of coherent activities that were in our reports. And to me, that's sort of one of the best things about this country, that American citizens historically and traditionally have had the sense that we are empowered to make change, and that it stems from the local level. And so, although we didn't have the lever of Congress with additional money, putting the ideas out there, we have found people who are willing partners, and that has just been an amazing experience to travel across the country. One of the things you mentioned going forward, all is not bleak. I mean, you often talk to people who contemplate the change in our administration, and it's gloom and doom, and go home because the sky is falling. That's not quite true. One of the things that to me was remarkable was that if you look at the Every Student Succeeds Act, ESSA, which if you're in K through 12 education, you know something about, a large part of the language that you will find in the ESSA authorization around STEM education are things that come from our Prepare and Inspire report. And so it shows that if you put out a message, even with people who are not disposed to being cooperative, if the message is actually grounded in reality, that eventually that message can make its way through terrible political times.
It's great to hear that message of hope. I would love to give you all a chance. I think we have time for, looks like 1 or 2 possibly, questions, and there's a microphone. If you could just identify who you are when you ask your question. I'm just looking around. Anybody? There's one straight in the back.
Hi, I'm Mary Gromko, National Science Teachers Association. And is there hope for the Eisenhower funds to come back again for math and science? Because ever since we've lost them, we've had no funding for science until just recently with the new Title IV.
Right.
The trouble with Title IV is it's open to all curricula areas.
Right.
Social studies, art, PE, and then STEM.
Right.
The war has begun for that money. So where is there help for teacher professional development in science?
So first of all, it's a great question. It's one that we wrestled with the entire time that we were serving on the council. And when I say we, I mean all of us on the council, because every single member of the council, whether they were university presidents coming from the corporate world, an academician like myself, we all understood that the investment in our science teachers was really, in fact, we always said that that's in fact the most important part of trying to create change, is focusing there. The story is, it's a mixed, my response to your question is a mixed answer. The current administration, interestingly enough, has preserved some focus on STEM education. And you may not read about it in the news, but if you look very carefully, you can find out that they have. They haven't aggressively set out large goals, but they haven't also simply cut back everything. Now, the disappearance of the Eisenhower funds, of course, is a great disaster in many of our opinions. And the only way that's going to change is that enough people like you and your colleagues at the local level, working through our Congress, comes to understand that this is something that's vital, that is recognized as of being of vital importance to the nation. It's going to, again, it's going to have to be, you know, we are proud of our American Revolution. Well, it's time to have one around STEM education.
Bottom up.
Thank you.
Other questions? Do we have time for one more? You have one? You can go.
You mentioned going out and seeing the local kind of galvanized forces out there, and a lot of the point of this meeting is bringing people together and doing something. And so where you saw successes in people coming together, organizing and making a difference, I'm curious, like, what were behaviors or signals to success? So
the first thing is that you need to have a community who wishes to be informed. And one of the ways to do that is actually to look at these reports, because as I said, we knew they would never result in a congressional appropriations, but they were statements about things that people interested in solving the problem could take under consideration. So the first thing is you want to have a community where people wish to be informed about what's out there. Our particular reports, Prepare and Inspire and Engage to Excel, are available to anyone. You just put the phrase into your Google machine and you hit the search button, and you can find the reports in their entirety. They're open to the public, and the ideas are there. And that's how, one thing that we see people doing in the adoption is that local people go and get the information about what's possible and then become the motivating and energizing force to make it happen.
Well, thank you. Jim, I think we're almost at time.
Sure.
But I was thinking, you've got a bunch of people in the room who are quite a good combination of educators, academics who care deeply about STEM education, are looking for what's the evidence-based approaches to what works, and some ed tech people.
Yes.
If there was one thing that you could leave the room with, they can take forward to try to make the world a better place in STEM ed, could you share some thoughts about that? That's a tough one, I know.
That's an assignment that I don't feel adequate to execute on. Yeah. I will neck that down to something much smaller, if you don't mind.
That's fine.
So I'm the father of a set of twins, a boy and a girl. They're 26 years old. And we're a STEM family. I'm a professor of physics. I love physics. You might see me on TV talking crazy stuff. It's what I do. My wife is a medical doctor. My twins, my daughter double majored in math and physics. My son got his degree in biology. And so what I tell people is start at home. If you're really thinking about being an advocate, start with your local environment. I don't know how to solve the large societal problem, but I've told people I think I know a solution that I can implement in my household. And apparently I was successful because we didn't make the kids want to be scientists, but they have wanted to become scientists. So start locally, think locally, and then I think that's a saying, think locally, act globally, something like that?
Yeah, it is, yeah. Yeah, I love that actually, because that's something that feels very approachable. That is one thing that we can all do, is start at home. And you remind me, in case it's useful to anybody, and I haven't mentioned this yet, Scientific American has free activities on the website called Bring Science Home. And it was the same idea. It's for parents of kids ages 6 to 12, and you can do these activities with things you have handy in your house, and they're free. I do find teachers use them a lot also, but I love that advice to go forth and bring it home, and by doing so, be able to bring it outward. I hope you will.
Can I add just one?
Do you want to add one thing?
But there's one thing. Like I said, there's one thing that you folks can do at home, and that's sort of control the culture. That's one thing we did, and I'll give you a couple of examples. My son spontaneously began to add when he was about 2.5 years old, and so we had a party.
That's all. That's a good
And
idea.
every time one of the children mastered one of the basic arithmetic operations, we had a party. So they got the idea that when you increase your ability to master mathematics, you're going to have a party. My daughter, I must say, is the one who mastered division. She was the first one. And boy, did we have a party. Thank you.
That's awesome. Thank you. Thank you very much. Thank you so much, Dr. Gates. That was really, really great. You actually remind me that I remember Obama said, "We will be the people that that we celebrate, the things that we celebrate." So that was a great, great thought to end with. Thank you. I'd now like to welcome back to the stage Anna Kuchment, who is going to have. She's a science writer at the Dallas Morning News and contributing editor for Scientific American, and she's going to have a conversation on evolution and virtual reality. I'm going to let her do the proper introductions, but thank you very much. There's a stand-up mic for her and this one.
We didn't have a chemistry act, so we thought we'd do slapstick to wake you guys up. So I wanted to welcome Becca Peixotto. She is an archaeologist, and she just moved from Washington, D.C. to Dallas to take on a new role at our Perot Museum of Nature and Science in Dallas. So she is now director of the Center for the Exploration of the Human Journey at the Perot Museum. But before that, Becca's claim to fame was really as an underground astronaut. So in 2013, she was one of 6 women to excavate the remains of a newly discovered ancient human ancestor from a cave in South Africa. And to get down there, they had to squeeze through an opening that was just about 8 inches wide. And so the expedition was led by a paleoanthropologist named Lee Berger, and they discovered one of the largest troves of new human ancestor fossils ever found. So I wanted to start by asking Becca to talk a little bit about how she got involved with that expedition, since it's led directly to her new role at our local science museum.
So in 2013, I was on a gap year, so to speak, between my master's and my PhD program, and an ad came up on Facebook. Let's see, this ad was posted on, the physical anthropology, biological anthropology groups on Facebook. Basically, it says, we've found this thing in a cave. I'm not going to tell you what it is. I want some folks who are small archaeologists and paleoanthropologists with caving and climbing experience, and can you come to South Africa now, and we might not pay you. So I didn't actually see this. A friend of mine saw this and sent it to me with a note that said, I think this might be you. And I very quickly fired off a CV and a cover letter, and thought, okay, well, that was good. At least I tried. And I didn't expect to hear anything back. And about 3 weeks later, I was underground in South Africa. It was myself and 5 other women who were selected to be the primary excavators. We were dubbed underground astronauts, and the pose in this picture is deliberate, because Lee wanted something catchy to say. And also, nobody knows what a pteronaut wasn't going to work. Speleonaut sounds silly, whatever. So we became underground astronauts, and it stuck. And the fact that we were 6 women, I think, says a lot about the field of paleoanthropology and archaeology. That, the people who were the most qualified with the combination of caving, climbing, excavation, analysis, all of those skills just happened to be 6 women. Amongst us now, there are 4 PhDs, I think 8 masters. We know what we're doing, and we did then. We've all since gotten more degrees. So anyway, yeah, that's how I got involved. And then the Perot Museum has had a partnership, or has had a relationship with Lee Berger since really 2013 or 2014, and various combinations of us have gone to the Perot to do outreach, give talks, work with schools over the years. And the Perot decided that they wanted to expand that relationship into a formal partnership and develop a center of excellence around human origins, human evolution, and hence the Center for the Exploration of the Human Journey.
So tell us more about the center and its mission and your new role there.
Yeah, the center only formed in May or just launched in May of this year when I came to the Perot Museum. Our mission is to be a catalyst for education and dialogue, and we want to become a laboratory for innovation and science communication with our roots in paleoanthropology, but in all of the allied fields that help us understand our human origins. So we have lots of outreach, education initiatives that we are just starting. We're only started in May, so we're just starting to launch some of those. And to really have a larger voice for human evolution in Dallas and in the museum. And it comes, we're lucky that the timing worked out. The museum just reopened their Being Human Hall with a reorganization that puts more emphasis on becoming human. There's a section of the exhibit that is becoming human, and how the things that we study as paleoanthropologists, or my colleagues and I study, related to bipedality, how those relate, for example, to things that modern humans do. So you might look at early footprints, and then you move into some activities or some parts of the exhibit that are looking at, your gait, and how do modern humans walk, and how has that changed over time, and how are doctors and physicians studying that now, for example. And it's like that with the hands and with, lots of things that make us human. Cool exhibit.
And you have really innovative ideas about the role that technology can play in helping you translate that field research to a broader audience. Mm-hmm. And so can you talk about some of those initiatives?
Sure. So one of the things that we run into with this cave, and I'll show you a video in just a few minutes, is that nobody can get there. Lee Berger can't get there. There's probably 24 people, 25 people that have been into the chamber where the fossils are. A combination of geologists, some of our cave safety, cave explorer folks, and then those of us that excavate, and that's it. Part of that is trying to protect the site, but a big part of that is in order to get there, you have to be able to fit through an 18-centimeter gap. Not only do you have to be willing, you have to be, or be able, you have to be willing. So those two aspects exclude a whole lot of people. So we want to be able to share the cave and what the cave looks like and what this really fascinating site where we've found more than 2,000 hominid fossils representing a minimum of 15 individuals, this new species that's Homo naledi. We want to be able to share that with our colleagues who are scientists, but also with students and with teachers. And so this year in the museum, we opened a virtual reality section of the exhibit. So you put on the virtual reality headset, you go into the cave, and you get an opportunity to pick up fossils, see the excavation, and hear part of the story of how this work is conducted. And here on the screen, you can see an actual picture of the, it's a little bit blown out on these screens, unfortunately, an actual picture of the Dinaledi Chamber excavation area from 2013. And there are orange and yellow lights in there. That's not a weird picture. We had LED lights lighting the cave at that time. And they had their like native mode was disco mode, so they'd cycle through different colors. So we have a few, it's always hard to find the remote to change it to plain white. So we have a few scientific photos that have like this weird purple hue to them, or in this case it's orange. Anyway, so that's the Dinaledi Chamber in real life, and then on the other side is the screenshot of the virtual Dinaledi Chamber. So it's a real, it's a pretty good representation of the cave and what it looks like. And there's 3D scans of fossils that then you can pick up and rotate around and manipulate in the virtual space. This is a stationary virtual reality exhibit, so you don't actually maneuver through the space. That's a bunch of reasons for that, including throughput for the museum and the fact that we don't want people wandering around with headsets on in the museum. That would be sort of a disaster.
And then you're going to build on that, right? And sort of have more new ways of using virtual reality in the future as well.
Yes, exactly. In a couple of weeks, we're going to be launching a version of this app to the public that's going to have narration in 6 languages, including 3 languages that are local to the region in South Africa where this cave is. They're all voiced by scientists who are part of the project. So I sent out a call to all of my colleagues. There's about 150 scientists on the project and said, hey, who wants to do a narration in their native language? And so we ended up with 6 folks. That's how big we could make the app. And it'll be a free app for Android and iPhone, and it's designed to work with Google Cardboard. So we have, the nice sort of manufactured Google Cardboards, but one of the reasons that I was excited to make this a cardboard app was to reduce the economic barriers to access to this technology. So we have partner classrooms who are actually making their own cardboards. They're making the little lenses out of soda bottles and water and gluing them together, and building the frames out of cardboard boxes, right? So we're sort of hoping to involve more classrooms in that maker, do-it-yourself access to technology as well. And then together with the app, we have a website that has a few lesson plans on it. We're hoping that more teachers will contribute lesson plans as they get an opportunity to use the app. And the lesson plans that we're putting up are matched to the TEKS standards. So hopefully that helps teachers figure out ways to use it in the classroom. So I have, just to give you a sense of what it's like in the cave and why this virtual reality is helpful. Is there a way to pause that for a second? Sorry, it started a bit before I, hello? Thank you. What you're going to see here is us removing a mass of sediment and fossil from the cave. Typically, we excavate the fossils individually, and then we package them individually and bring them out in their very small little packages. In this case, we weren't able to do that because of this particular area of fossil and sediment, so we brought it out on block as a big chunk all encased in plaster. And what you're going to see here is us moving this 26-kilo block up this 12-meter vertical chute that's 18 centimeters wide as its narrowest point, and then out the rest of the cave system. And it's sped up, so it only takes about 2 minutes. In reality, it took us close to an hour, which we thought was really fast. Thought we were going to take longer. But I'm showing this video so you get a sense of what the cave is like, and also the fact that this is a really, really collaborative project. You're going to see people in this video who are sort of our technical experts doing the rope work, managing the rope work for us. You'll see, what you won't see here are some of the other folks that participate in the analysis and help us with the other technology aspects, the 3D scanning and that kind of thing. So, no. Here, yeah. Will it go? Please? Thank you. So that's my colleague Marina. You're looking at the video. Most of this is from my helmet cam. Some of it will be from Marina's. And there's that bag. It's sort of shaped like a torso, just because that's what would fit out the hole. And there you can see Marina using her body as a boost to get the bag up high enough through a slot that it would fit. And the bag weighs 25, 26 kilos, so 50 odd pounds. And here we are sort of on a controlled zip line, lowering it down that area is called the Dragon's Back. It's a very narrow fin of rock that if you were to fall off of, it would be catastrophic. So one of the things I like to talk about when I talk about this project with students is really the teamwork aspect of it. And we hear a lot about, particularly in human origins, we hear a lot about single scientists that make these grand discoveries, and that masks the reality of massive teams of people working on these projects. So it's dark in the cave. It's proper dark in there until you get right to the entrance. And there we are coming up to the surface. So anyway, and this is a photo that some of you may have seen before of about a third of the fossils that we had recovered at that time. We've now got more of Homo naledi. And you can see there's lots and lots to talk about. I actually have some second graders who I'm working with that we gave them 3D prints of the fossils and didn't tell them what bones they were, and they were doing comparative anatomy to figure out what bones were what, and it was pretty cool. Second graders have great little minds. It's awesome. I don't know if I have.
Yeah, and at the museum you have these amazing 3D prints of the Homo naledi skull and different bones, and then you have kids doing like actual hands-on activities, right?
Exactly. A lot of the fossils are scanned and available on Morphosource, so anybody can download them and print them if you have a 3D printer, or if you don't have a printer, you can look at them on your computer screen and manipulate them. So it's really, that's part of the ethos of the Rising Star expedition is open access, and so most of the papers we publish are published in front of the paywall and not behind it. The app will be free with other ways for reducing barriers to access. The fossils, you can access them and do your own analysis of them, or have your students do analysis of them. So it's exciting to be a part of a project like that.
Yeah, what I like best about this project and the museum is that often when you go to a science museum, because exhibitions are so elaborate and they take so much time and expense to design and orchestrate and install, when you walk into a museum, especially when you're walking through a human origins or evolution section, you get the sense that everything's already been discovered, right? That there's nothing else no other questions, it's sort of settled science, a bunch of facts that you can memorize. But through this partnership with Becca and her team, they're going to keep updating the exhibition. And Becca, at the end of this month, is going back to South Africa to do another excavation, and she'll be doing that repeatedly. So I was wondering if you could talk about how you're going to kind of include your new discoveries and new experiences in the exhibition and in your communication efforts.
Yeah. I'm working with our exhibits team in the museum right now to there's a bunch of video screens in the exhibit, and we're going to try to take one of those video screens over for the period of time that I'm underground, that we're excavating, so that we can send back videos of, this is what we were doing in the field today or yesterday, and here's the fossils we found yesterday, to sort of update what's in the museum and show that this is work and this is research that's ongoing, and we don't have all the answers about human origins yet, and we're trying to find out, and that's really cool. And then also the pitch for all of the teachers and educators out there. We like to do outreach when it's part of our mission when we're excavating. So if you want to connect with us virtually, either from underground or in other ways with your classrooms, certainly reach out to me, because we like to talk to students. We have a few systems for doing that. So.
Yeah, on that note, I wanted to ask you generally, how can educators best interact with the Perot Museum and your new center?
Yeah. Wow. If you have ideas, let me know. I'm open. We don't have a long tradition of things that we're trying to fight against. We're trying to create new ways. So if you have ideas of how you want to interact with us, certainly reach out to me. We're on Twitter at Perot Museum, CEHJ. I can give you my cards. You have my email. We'll have, once the website and the app are live, we're certainly looking for people who are willing to contribute lesson plans and share their experiences working with, using the app and using the lesson plans in classrooms. Yeah.
Great. Well, I'll just ask Becca one more question, and then I'll open it up to questions from the audience. So in your experience, what have you found to be kind of the best ways of engaging the public in paleoanthropology and in what you do?
Yeah. For me, and I think many of my colleagues on the project find this as well when we're speaking with sort of general audiences who may or may not have an innate interest in paleoanthropology, the exploration and discovery side of this. We're doing lots of different kinds of science in this project, but it's all coming from a point of curiosity and a point of exploration and what's around here. The Rising Star Cave is a couple hundred meters from the earliest known controlled use of fire. We're a couple kilometers from sites like Sterkfontein and Malapa, other major early hominid sites, but no one bothered to look in Rising Star until 2013 because there were all these other sites that were really interesting, and so scientists sort of got a little bit myopic and just really concentrated on sites they knew were there. And what we're finding with Rising Star is there's a lot more in our backyards than we really understand. And so starting from that point of exploration and what's around here and what could we discover, what haven't we seen yet, even though we think we know this place really well. I think that to me helps with getting those conversations started. And then I can talk about the fact that we found a new species of early human relative called Homo naledi, and it's roughly 250,000 years old, and it's got this crazy mosaic of characteristics, some of which are very much like modern humans, and some of which are really like some of our more distant relatives. And we can talk about, that opens up the space for those other kinds of conversations.
Thank you. Do you have any questions for Becca? Okay.
Hi, Elena Winslow from Chick Tech. So one of the things I think about museums is they have a long history of being interactive learning spaces, and you've talked a lot about some of the cool things that you're doing in your museum. And I'm just wondering, do you have any kind of favorite resources kind of on interactive environment design or something? Because I feel like they could be really inspirational for educators as well when they're thinking about their classrooms.
I don't. I have been in the museums for 4 months. And we have a really fantastic exhibit design team at the Perot. And that's not my area of expertise, so I'm sorry. I can put you in touch with them, though, but...
Sure.
Yeah.
Can you state your name? Sure. Hi, I'm Jim Morris from Brandeis University. I had three kind of interrelated questions. You said how narrow the cave is, but I'm curious how deep the cave is. I'm also curious, you said the fossil's about 250,000 years old. Do you know how it relates to other groups in the area? And finally, for sort of the education piece of it, how did you do the virtual reality? Did you, maybe you mentioned, but did you team with another group, or how did that collaboration work out?
Great. So the cave, the Dinaledi chamber is 30 meters underground. We don't go straight down. We take a sort of a sloping route. The route is about 150, 200 meters long, the route that we take. And when we first started going into the cave, it took us upwards of 45 minutes. Now we've all gotten in better shape and have learned the route, and it takes 20 minutes to get there, depending on how much stuff we're carrying in or out. But it's 30 meters if you were to go straight up from the surface. Relationships with other species, we're not sure yet. We know that there are stone tools on the surface around the cave that are coming in really close to that same time frame, but we don't have anything in direct association with Homo naledi to be able to make good, clear statements about that. It's one of those areas we're still trying to find out, and some of the exploration and the excavations we're doing now, and the partnerships we're building with other researchers are aimed at answering that question, like, what's Homo naledi doing in this landscape? Who else was around? How were they interacting with each other? Yeah. And then for the virtual reality, one of my colleagues wrote a dissertation about the cave using 3D scanning. So they went through the cave system with a little tiny ball and did 3D laser scans of the cave. That forms the framework of the VR. And then just this past spring, we went underground with a 360 camera. It's a little ball thing. It looks like that thing Luke Skywalker battles when he's practicing on the Millennium Falcon. And it has little cameras all around it, and we shot a lot of still and video footage using that then gets overlaid over this 3D scanning framework. Yeah, and then we've partnered with, there's an app developer we're working with that's actually put it together, because I don't know how to do all that.
But I wanted to add that I think Becca shot all the actual virtual reality video, for that.
Yeah, we went, my colleague Marina and I went there.
Hi, I'm Tom Dubick from Charlotte, North Carolina. This is totally a newbie question, but you've gotten the fossils out. Do you keep digging deeper then? Is it like a piece of ore of silver where you keep digging until we don't find any fossils, and how far do you go?
Yeah, so when we excavated in 2013, we recovered roughly, so the first round of excavation, we recovered roughly 1,200, 1,300 fossil elements. Some of that was just cleaning the surface, and then the rest of it was excavating a unit that was less than a meter square and only about this deep. And then since then we've excavated deeper than that to see if, does this density of fossils continue? And it turns out it doesn't. There does seem to be a bottom. So there is a little bit of excavating down. Other things that we've done since then, excavating in other parts of the chamber and other parts of the cave to see where there are and aren't fossils to help us understand the distribution around. And our excavations are really based on research questions now. At first it was, there's fossils. What's this about? And now we're able to ask more directed research questions. How are they getting into this chamber? So we're going to excavate in a particular area that we think might be an entrance to the chamber. How are these fossils getting into different parts of the cave, and are the fossils we're finding here, are they parts of the same individuals that we're finding downslope? Is there any kind of transition like that? So we're really picking now carefully the areas that we excavate based on research questions. And it means that when we go back this time, I believe we're going to be back into that same 2013 area that we haven't excavated in a couple of years. because we've been busy analyzing those fossils and trying to understand that space. So we've been excavating elsewhere while we're trying to understand this. Now we think we have a handle what's going on there. We've got some new questions. So we're going to go back and revisit that area, see if we can answer these new questions and see how all of this different information informs itself. Yeah.
I think we still have time for a couple more questions. Yeah.
I think I can be loud. I have an even more basic question. Is it just terrifying to be I can't fathom ever getting over that. Do you start out a little nervous and just get used to it, or what's the process?
So in 2013, the first time I went into this cave system, we did a little training beforehand. We went into other parts of the cave system to sort of get acclimated. Mostly, for me, it was mostly getting acclimated to the team, right? I'm going to trust these people with my life. I better know that they're not going to lose it underground either, right? So safety is, it's the top priority. We're always double checking each other and the equipment and where we're going and, has anything shifted or things changing, what's going on the surface and all of that. Yeah, so I stay pretty focused underground. And so, I don't know, it's dark. I hope my batteries, carry 3 or 4 extra sets of batteries, and I always know where my friends are, so I feel pretty good about it. We have communication now between underground and the surface, both with Wi-Fi. We have really strong Wi-Fi underground, which is pretty awesome, and with like an intercom system, like a little telephone system that we run cables for. So, we have opportunities to communicate to the surface if we need to. Yeah.
Okay, well, thank you so much, everyone. Thanks.
So thanks a lot. That was really, really amazing. And I was freaking out just looking at the pictures. I'm happy to tell you that we have a little time for a break until about 10:35. Can you please meet us back here? Please enjoy coffee, tea, and so on. Thank you.
twillig and the slithy toes did gyre and gimble in the wabe. All mimsy where the burrow goes, and the mome wraths outgrabe. Beware the Jabberwock, my son, the jaws that catch, the claws that bite. Beware the, beware the jub-jub bird, and shun the frumious bandersnatch.
Hello? Yeah, all right. Hi, everybody. Yo! Yeah, that was good. I like that. If we can please come in when you get a chance, that would be awesome. Thank you again, Jim Gates. Is heading off. Okay, come on in. I'm going to come up where you are, Dan. And I'm going to hang out here. Okay, everybody. Hi again. It's Mariette here. Hope you had a nice coffee break. What a pleasure it is to introduce to you my friend Dan Russell, who works at Google, who has probably even a more awesome title than I have. Uber Tech Lead, Google Search Quality, and User Experience Research. And I for that, almost that reason alone, you know, you would be amazed, but he's going to tell you many other amazing things. And I would like to say, take it away,
Great.
Dan. Thanks so much.
Thank you. And how many minutes do I have?
How many minutes?
Can I get like 3 more?
How many do you want? How many do you want?
Well, this is a 30-minute
What are you
talk.
asking for? Yeah,
but
no,
I can talk for 8 hours.
Now, we're going to do the 30-minute.
Okay, got it. So thank you. I'm happy to be here because we live in a complicated time. So first off, unlike you as a teacher in a regular classroom or regular conference setting, you need to get out your phones and or laptops for this talk because we're going to do a little bit of work together. Now, the truth is, I'm actually a professional AI guy. And so when I was a student, I studied first-order predicate logic like this. And the reason I bring that up is it's kind of, it's a real way of framing epistemology, which is a fancy word that says, how do you know what you know? Now, we live in a time of sort of endless contextual arguments and universal brouhaha. And you know what I'm talking about. How do you know what's true? How do you know what's a fact? How do you know what's to believe, what you can believe in? So the thing I want to bring to you from epistemology is, you know, there's a whole pile of epistemological theory. Ignore that. Not useful today. What is useful is to think about what we read and what we write, what our students hear and take in, is a set of assertions. So each one of those lines up there is an assertion. And the truth value of that assertion is something that's determined contextually, possibly later, and it may possibly change, right? What is Zaire, for example? How many planets are there? Are there 9 or 8? Depends on when you ask, right? Zaire used to be a country in Africa. It's not anymore. It's just a memory. So truth values change over time. So I want to decouple this notion of fact from assertion, right? You can assert anything, and the factual validity of that, the truth value of that, is something separate. Because, remember this? Yeah, what color is that? It depends, right? It depends on the context. It depends on who you are. It depends on the background. It depends is the answer. There is no single truth value for that. White or black, gold or blue, yellow or turquoise, whatever, right? It turns out that truth is a difficult thing. And in particular, I think Snopes has it right when they sometimes evaluate statements or stories they read by saying it's a mixture, right? Truth is complicated. Facts are even more complicated, but I think the notion that you can have truth as a mixture of truth values is an interesting notion. So the truth is, we think about credibility as being a reliable, trusted resource, but in truth, there's that word again, it is a subjective measure. For instance, credibility assessments change by topic, time, person, context, need. So for example, I trust my mother. My mother has huge credibility about things like child rearing or music or, you know, the sentiments of Southern California. But quantum mechanics, not so much, right? So different people, different contexts, different times have different kinds of credibility. So, for example, there's a set of common beliefs that people have. .com is more credible than .org. .net is more credible than .com, you know, so on and so on, right? One common misbelief is that Google search results are sorted by credibility. They're not. We don't know how to define credibility because we don't know your context, right? So we might think, for example, that a site like scientificamerican.com is credible. But here's an interesting thing to know. If you type in, go to a main name server salesperson, and you say scientificamericanstem.com, did you know you could buy that domain name for $2.99? Is that a credible site? You don't know, right? The bottom line is you can go off and buy all these domain names, .org, .net, .x, and so on, for small amounts of money and masquerade as Scientific American. Or your favorite congressperson or your favorite academic institution. It's not hard to do. So what's credible, what's authoritative, what's factual is a really interesting mix of all these different aspects of truth and of fact and of assertion. So here's a question for you. What's true? What I really wanted to talk about today, though, is how do we teach our students to figure this out, right? You, the sage on the stage, the guy in the box talking, saying things that are more or less true, are a credible resource. How does a student know? How do they know? You might go, for example, and say, well, the films of Thomas Edison are a credible resource, especially when there's a ton of metadata for this film Thomas Edison shot. It's labeled here by the Library of Congress as being shot in Cuba about the Spanish-American War. Now, this is actually fascinating because I'm going to skip through this quickly.
From the Library of Congress in Washington,
Yeah,
D.C.
credible resource, right? Now watch. So this is a recreation, this was billed as an incident in Cuba during the Spanish-American War, right? Now, the thing about this is when you watch it, A, does the vegetation match Cuba? Not really. B, the metadata says these sharpshooters are shooting over the body of dead horses. Now, this is really fascinating. I'm going to fast forward a little bit to here. Watch the horse on the far right. Oh, it got it. Thanks, Library of Congress. It gets up at the end of the film.
In Washington, D.C.
Yeah, we know. So now that you've got your phones out, I want you to start thinking about this question. What place did Mike Losey get in the Palo Alto Moonlight 5K run in 2017? Go ahead, start working on it while I'm going to give you a minute to work on it. Because the reason I showed you that video, that film, was it was actually filmed in New Jersey. Filmed in New Jersey. Those are New Jersey pines in the background. And those were guys from Edison's lab recreating the incident that supposedly happened. So is Thomas Edison an incredible resource? Not so much, right? So now I'm asking you this question here for two reasons. A, I gave you a minute, so we still got like 15 seconds to go, because that's more time than your students will take to answer a question. You know this is true. I know it's true because I can look at the search logs. I know that lots of student questions or student queries that come into Google, because I know they're student queries, because they're often space. What is the root of this equation, y equals x squared plus b, right? And so the fact that they put in the 2 dot means they're just copying it off the test, right? I can find millions of queries like that every day. And I also know then that students in particular, go in, do the search very quickly, and they're done. Okay, who's got an answer? Anybody? Okay. What are the rest of you doing? Okay, so what was your query? What did you do? Susan, tell us what it was. Right. A, it's amazing that works, right? It's a guy in a race. And then how did you find that he was number 50? And then you scroll down the page? What did you do? Yeah. 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 How did you find his name, though, in the document? You scroll down in visual search. What did you do? Yeah. Yeah. You scroll down until you saw his name. Okay. It was. It's not the first one on the page. It's the first one. Oh, you did. I see what you did. Okay, that's a slightly different path. Anybody else? What'd you do? How did you search for him? And then how did you do that? Show your work. You did the filter at the top. Okay. How many people used find on page or Control F or anything, right? Okay. One person. Okay. My real question here is, he's at the bottom of the page, and so if you're on a Mac, you would do that, Command F, or if you're on the other device, you would do that, Control F, right? Question for you, how many of you have never heard of Control F or Command F before? Anybody? So here's the thing. When I asked this in a larger setting, doing surveys of thousands of people, 90% do not know this. They do not know how to find text on a page. Are you as shocked as I am? That means 90% of your students do not know how to find text on a long page. When I ask English teachers in the US, half of them don't know this either. Excuse me? Half of them don't know this? This is important because when you've discovered that people don't know how to find text on a page, and if it's a long page, they're screwed. They're going to do visual search. Now, I did another study where I asked 85 people through a complicated study method to do this question: how long did it take him to run? See that? There's a bunch of people like you over here on the left in that first spike at under 10, 15, 20 seconds. There's a bunch of people over here beyond 300 seconds. That's 5 minutes, right? What are they doing? They're searching by hand. They're scrolling through this, right? It's crazy. Now, the fascinating thing about this is people who take more than 120 seconds, more than 2 minutes, a quarter of them get the answer wrong. You might wonder, how do you get the answer wrong, right? The reason is, I had them take the time. I actually asked how long did he take the time and put it into my survey form. Copy, paste, right? These people don't know that either. So they manually typed in the number they thought they saw. And it doesn't work well. People get errors all the time. And so we have a huge number of people, 90% of people, don't know this fundamental search skill. If you're reading an ebook, say, from your favorite publisher, and you don't know how to do find on text, you do not know how to do things like this. So for example, if you're reading Alice's Adventure in Wonderland and search for Jabberwocky, you get 0 hits. If you don't know how to do that, that's going to take you a long time to page every single page, right? So what you can do with this search skill, this search strategy, this search tactic, is discover that something is not there. You can prove the negative. How often in your life can you prove the negative? Not often. This is one way to do it. Question, the deeper question for us as STEM teachers, who taught you that? Do you remember? Probably not. The answer is nobody. You saw somebody else do it and you looked over their shoulder. That's how most people learn their search skills. Question to you, we as a field should be taking this challenge seriously. We should be figuring out, how are our students learning to do online research? It's not part of the curriculum, right? So this becomes really important when we live in a world where increasing amounts of content are not just made up, but they're consciously fake. So here's a set of images. Just choose one you think is real. I assure you, half of these are real. Choose one you think is real. Now I'll show you the answers. Did you correctly pick a real one? Or did you decide on a computer-generated one? Did you get it right? This is particularly problematic because, as you know, we live in an era where videos are becoming complicated objects. This is a video purportedly from CNN. Wait, why are you laughing? This is the Holy Father doing a miracle. Skeptics. Why are you skeptical? right? I mean, you have a lot of common sense about this, but how about this? You probably saw this movie. Which one was real? Which is the synthespian, right? And of course, you probably have seen this. I'm not going to show you the video. You can go look at it later. It's linked to in the latest issue of Scientific American, actually, where there's this really, really nice article that links to that video, the fake Obama video. So it's that article. It's available in the hallway right now. That's right. And in the bag, right. My point is, we live in a world where this kind of stuff is not only increasing in volume and fidelity, it's coming more and more difficult for students, for us, to figure out what's BS and what's not. So what do you need to have? What do I teach my students to do? First, I teach them sort of an attitudinal thing. Question stuff that looks suspicious. Question stuff that doesn't look suspicious. How do you do that? Here's one thing that I've done. I often teach at large conferences of teachers and English teachers, and I ask them this question. How many of you have read this book? How many of you have read this book? Right? Most of you, right? English teachers, uniformly, they all have read this book. They teach this book. So, question for you. What does the title mean? Almost uniformly, teachers will say, oh, this is about the Nautilus, right? It's that submarine. And it's how deep it goes below the surface of the sea. Okay? So I said, well, wait a second. What's a league? And they said, I don't know, it's some archaic unit of measurement. What is 20,000 of those? So let's look it up in Google. Define it. It's a distance, about 3 miles. So what's 20,000 leagues in kilometers? It's 101,000 kilometers. Cool, the English teachers say. I like that. Now I know it's 100,000 kilometers. Then I say, what's the diameter of the Earth? You have a problem. You did not understand the title of the book you're teaching. You didn't understand the first 2 words. What does that say about us as educators? So it's changing, you know, our technology, the availability of information online is changing the way we think, right? But while we've always taught critical thinking and critical resource and critical analysis as a thing to do, it's really, I'm not kidding this time, it's really critical. Don't have time to do this, but I will walk you through it. If we had more time, just saying, if we had more time, I would ask you, what about this website, EPAFacts.com? The reason it comes up a lot is that it shows up in lots of student papers when they're writing about the EPA. They search for the EPA and they end up on this site. And you look at it, it's sort of funny. So you as an adult who knows about the EPA, the one, the true, real EPA, the platonic EPA, right? You might wonder, why do they have transparency problems on their first page of EPA? Why is it EPA.com? But if you're in the 6th grade, you don't know that .gov is a thing. So that doesn't trickle your spidey senses at all, right? So if you go look at that site, their mission statement is they're a Project Environmental Policy Alliance dedicated to highlighting the high cost of the environmental protection. What? If you're in 6th grade or 7th grade, again, that's like, okay, that seems fine to me. Let's go look at the other one, the EPA.gov. Their mission statement is a little different. It's an independent agency, blah, 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 right? So how do you, as a student, how do you, as a citizen, how do you figure out whether or not that's a credible site? What would you do? Suggestions? I'm looking for feedback now. Okay, how do you do that? How do you do that? Yeah, I know. That's what everybody says, well, just Google it. You don't know how to do that. I'm not blaming you particularly. It's just, I think it's too easy to say, oh yeah, I'll do this, but I don't know how to actually do it, right? So here's an easier way. You could, for example, go and check the executives of each organization, find who they are. But here's an even easier way, which is they have their street address at EPAFacts.com. It's 1090 Vermont Avenue, Suite 800. What's the address of EPA.gov? Something different. But interesting, here, I'm going to put that street address into Google, just copy paste what I have up there, into Google, and you will find out very quickly that is also the street address of this company, Berman & Co. Who are they? Doesn't take you long to figure out that they're actually a front for high-tech lobbying companies. They do a lot with big pharma, a lot with big ag, a lot with big oil. They are not the EPA, even though they represent themselves with an almost identical logo. So that's a really easy way to find that out. That's the true address of the true EPA.gov. Now, here's the thing that scares me. My colleague Sam Weinberg at Stanford has discovered that 80% of the students graduating from the university cannot do what I just showed you. They cannot determine that that's a bullshit site. It's a lobbying site. That should scare you. What it means to me is that we're not teaching our students how to actually do online research, let alone chem research, right? Chemistry research is important. You have to learn those fundamental lab skills. Who's teaching the lab skills of online research, which everybody uses every day? We need to figure this out because we live in a world like this, where you can go read the NewYorkTimes.com and discover that Warren endorses Sanders. Spoiler alert, this never happened. But there are sites that allow you to fake the presence and visual appearance of well-known, well-credible sites. It's hard to argue with Abraham Lincoln. But if you're in the 7th grade, again, you may think that's totally plausible. Now, you probably have seen this website, treeoctopus.com, right? It is a spoof site, I'm telling you now. But our students need to not only know the tactics of search, but also the existence of consciously overt spoof sites. That's not so hard, that's pretty funny. Thousands of 6th graders write articles on this website every year. They don't get the joke. But a more scurrilous one is this one, dihydrogen monoxide, right? Think about that for a second, it's water. The thing that's difficult about this site, every assertion on this site is true. In the extreme case. Yes, you can die from an overdose of dihydrogen monoxide, right? Overexposure to the altered crystalline state of this can also cause death, et cetera, right? It's all true. But it's a joke. It's a spoof site. This is important because there's a community in Southern California that when they found this site, the city council banned the importation of dihydrogen monoxide, which really pissed off the water department. How do you know? And why do so many people get fooled by this? So the last sort of tactic I think we need to be teaching is something like this. So here's an image. Again, if we had more time, I'd let you actually work on this. The best solution I've seen is I showed this in one class, and some woman walked up and with her phone and took a photograph of it. And using Google Photos said, where is this? You probably know where it is. But using Google Photos, it basically tells you this is Notre Dame. And once you've got that information, in Paris, not the other one, right? Just so you know, right? Once you know how to do that, all of a sudden, the way you think about search changes radically. There are new things happening all the time. And I'm going to run this a little bit, and I'll give you sort of background voiceover here. This is a little bit of the Google Earth VR system. And the reason I'm showing you this is because the world is changing. The online information world is adding new capabilities, and so this runs now in our lab. So this is a VR system you can fly through, which is based on Earth imagery. And you can see she's got a wand-like pointer, and she's flying around, in this case through Manhattan. You've probably seen that building. But now she grabs the sun and moves the sun backward in time. That's home. See what I'm saying? Unless you know how to navigate and use this for educational purposes, you could be in a world of hurt. So there are ways that I think we have reason to be optimistic. So I teach an online class, an online MOOC, called Power Searching with Google, which teaches this stuff. And I've now passed over 4.1 million students. And this is the killer graph of the entire talk. This is showing you that that period from September 3rd, you can barely see it. You see it in blue? That's when the class was being held. I tracked, what was it, 300,000 people or so after the class for 2 weeks. And you see that black line at the top? When they came in, they were at 0.4. When they left, they exited 2 weeks later, they're at 1.4. I tripled their search skill, and it stuck around. It is a persistent change in their search behavior. So we can do this. We can teach the world to be a better searcher. And I want to give you this sort of remix of Alan Toffler from 1970, that tomorrow's illiterate will not be those who cannot read and write, but those who can not learn, unlearn, and relearn. Because that Google VR thing didn't exist 3 years ago. It didn't exist when you were a student. When you were learning geography, it was not around. Trust me, we're not going to stop innovating new stuff. And I'm not just talking about Google, but all of us, right? So we live in a world where there's a breadth and depth of information that's unparalleled in human history, right? There's all kinds of new context, a chaotic media landscape. And search and online research can, at its best, lead the savvy to a deeper and more nuanced understanding of the world. But at its worst, it can lead students to this kind of collection and a trivial view of the world. Most of it spectacularly wrong, sensationalistic, and untrue. But there are ways we see new literacies arising. And that's why I think we, as a collection of people, need to actually figure out how to teach these online research skills. And it's not just to pump up my Google product. You can use Bing, I don't care, right? But you need to know how to separate the goats from the sheep, the untrue from the sensationalistic, and the factual and what's credible. Thank you very much. All right. As a coda, I have a book coming out next year on exactly this topic. So I'll come back next year.
First of all, that would be awesome. Thank you. And I'm glad you put your blog up too, because one of the things I wanted to ask you about was how do people keep learning about what the latest algorithm changes are and so on. I wonder if we have a few minutes for questions. I wonder if anybody has anything they'd like to ask Dan. And if you do, just please say your name and where you are. Any questions? So Dan, I have one for you. It's a little
philosophical one.
It's a little philosophical. You know, since you work in AI and so on, also. Although I don't know if we can answer this question. You know, a lot of times it occurs to me, a lot of our engineering is about protecting us from ourselves. For instance, the first time I ever met Larry Page, he sat down and said, "What problem are we going to solve today?" You know, and we were trying to have lunch. But it was a very Larry question. And I said to him, when are we going to see self-driving cars? You know, because I knew, you know, that he was passionate about them because, you know, we lose a lot of young lives, young drivers, because they don't yet have the skills of more seasoned drivers. So the question I have for you is along the same philosophical lines. Will machine learning, AI, whatever branch of it, somehow start to be able to protect us from ourselves? Because although those of us in the room and maybe some others can get better at search, we know some people will miss the lesson, right?
Yeah, right. So let me give the optimistic answer and the realistic answer.
That's cool.
The optimistic answer, and you'll hear a lot of people say this, is yes, we will get the ML algorithms to work, and we will just purge all that nonsense from the web. The realistic answer is not in my lifetime. It will get better, and we will be able to do a few things that clearly are contradictory or not based in reality, that kind of thing. But the problem ultimately is we live in an adversarial world, right? So you know about the existence of spam. So why do you still know about spam? Spam is like a low-grade fake news, right? And we have a whole team of people, like 100 people. That's all they do 24/7 is fight spam. They're still fighting spam, and some of it still gets through. That's the same problem we're going to have with falsehoods, with fake news, with outright lies, with misinformation, and so on. So it's trench warfare out there. And so no, we will never have the universal solvent that will make everything clean and beautiful, but we'll get better. Okay?
Thank you. Any other questions? One right here.
My name's Melissa. I was wondering, I've heard that there have been classes on this in countries in Europe.
I don't know a lot about it, but I've just heard that there have been classes on learning how to filter information for what's true and what's not, outside of just scientific classes. Do you have any sense of if that would take hold here, or if there's any interest in school districts in having a class like that, almost critical thinking in the modern world?
Yes, I think so. One of the things that surprised me about my MOOC was that for a long time we had a 12 to 15% completion rate, which is standard for the course for MOOCs. And then I checked it, and it was going up. I thought, wait, how is that possible? I mean, isn't it steady state? And it kept going up, 20%, 25%, 30%, and now it's like 35% completion rate. What is going on? You know, and so I ended up looking at, I spent probably a few days looking into this, doing logs analysis, and I discovered that you got all these square waves of people going online, like 50 come on at this time. They come on every day at 9 a.m. Like, what? Another group of 50 come on at 2:30 p.m. Another group come on at 1 a.m. Like, what is happening? Yeah. It's classes, right? It's Mrs. Brown's information literacy class in Madras, India. So you got 50 kids, they all go online simultaneously, they all drop off simultaneously. That's where the square waves come from. So somebody out there is using my materials for their information literacy classes. Some in the US, mostly in India, Brazil, and Europe, in that order. So yeah, my stuff seems to be being used in that style. So I think from a teacher on the ground's perspective, they need materials that they can use, right, and they can trust. So I'm in the business of basically trying to create some of those. And I think the more we create these materials and make them available, it's will help everybody do it. So I think it will happen. I will say, as a side note, these materials need a lot of care and maintenance. Every time I give a talk, I have to change my slides, every single time, because things that I wanted to show you are gone, or things that resources I wanted to show are gone. We were talking about digital preservation, right? This is a huge problem. So it's a huge opportunity, I think, for us collectively as educators and educator designers.
Thank you. Any other questions? There's one over here. Or maybe wait for the mic just because we're filming, so people will be able to hear
I just thought I'd show you the Notre Dame example. I'll show you one more while he's asking his question, because this is fun. Go for it.
I'm really freaked out by this slide that you have up there, Dan, by the way. Please don't buy those.
Oh, well,
too late.
Oh, wait, I'm not, why am I not seeing?
I don't know, but this is all I can see.
Oh, yeah, okay, let me get rid of that. Okay, go.
Oh, hi, I'm Jim from Brandeis. I thought I'd end with a sort of a philosophical question. Your premise at the beginning was about like what truth is and whether it's contextual, and you made the point that so much answers depends, like you mentioned the planets. How many planets are there?
Right.
It's 8 or it's 9. Yep. But in reality, I would say, well, there is some number of objects out there, and we just don't know how to name them, and it's around naming them. Or even the dress example is, it's emitting some, there's a frequency of light, and how you perceive it is different, but there is a measurable frequency. So my question for you is, do you think truth is something out there, or do you think it always depends on our experience?
Truth is out there.
The truth is out there. Yeah, thank you. You know, yes, there is a measurable frequency of light that comes off the dress, and it almost doesn't matter, right? Because in particular, color perception is so mediated by so many neurological things and so many experiential things that it almost doesn't matter. Having said that, I really am an objectivist. I actually do believe there are true facts in the world, but I will say, I think all facts, including simple things like, 5 plus 5 equals 10, they're all subject to time and place and condition and context. So for example, 1 plus 1 equals 10 in base 2, right? But you didn't say it, so it was assumed context, right? So I think that's part of the trick here, is you have to understand what the context is and whether or not it's shared universally. So simple things like, number actually have different sort of cultural and language determiners that actually shift your perception of them. So even though we love to think of mathematics as this beautifully constant thing and parallel lines never meet, in fact, there are geometries where parallel lines meet. And so that's not part of the assumed context. So we have to be aware of that. That's what I'm saying. So I think you're right.
Dan, that was fantastic. Thank you
Good.
so much.
Thank
Please
you.
join me in. Thank you. Maybe Dan will be around a little while if people have other questions. Thanks a million. So Kiara, I think because we made a little switch, we need to just plug your presentation in, if you don't mind. And while you're doing that, thanks again, Dan. While you're doing that, let me just give you a quick introduction. So I first met Kiara a couple of years ago when she was a little younger, but still much taller than I am, as one of our competitors for the Google Science Fair, which she'll talk about. The Google Science Fair has been going since 2011. There's a global competition that's open to all with Google's free platforms to use, slides and video and so on, which I think is really great. And it is a way for young researchers to share their work, to get involved and share their work. And I've been the chief judge since 2011 when it started. It's one of my lovely privileges and one of my favorite things, and that this is how I got to meet Kiara. Now, Kiara, you're going to talk a little bit in your presentation about your the research that you did for your award too. Okay, so I'll leave you to do that, but I just want us to give Kiara a warm welcome. She had a tough time getting in, and we're so happy to have you here. Thank you so much. Sorry about that. While they're doing this, so let me just tell you a couple other things. So the Google Science Fair, it has a grand prize winner, and it has a few other winners every year. It also does regional prizes in the large global regions, and this year it has a new aspect of the awards, which I'm very excited about, which is recognition for 50 winners across all 50 U.S. states. And this is sort of in keeping with the Google principle of it should be access for everybody, and we should try to recognize, more folks who don't necessarily get the chance. Oop, how's that coming? Pardon? So people can, I should have said, the Google entries are now open. They just opened a little earlier in September. The awards event will be in July, the final awards event. But all you need to do is go to googlesciencefair.com. It's very simple. And you can get a look at both not just the entry platform, but also get some ideas for great projects and generally find inspiration. Look at the past ones. We have some great videos of the past winners, and it looks like a lot of fun, as well as like a big inspiring thing to do. I think we're almost there. It looks like we're just getting it live.
A little pause here because we have to switch to the back.
Okay, we have to switch to the back? Okay. So while we're switching to the back, maybe this is a good excuse to ask people if they have any thoughts they might like to share about things they saw in the past, in the morning, maybe this morning. Is anybody going to be doing crazy chemistry when they get back home? I kind of can't wait. I'm a little afraid about the nitrogen, but I love that stuff. Have you ever just dropped marshmallow in there? That's pretty fun. Any thoughts anybody wants to share on the morning? Everybody's tired. I don't blame you.
They were all chemistry demonstrations, but I was thinking of my biology teacher, and there are some really nice connections to biology you can make using the biology class. The CO2, the dry ice, and CO2 exchange and the acidity of water is very relevant to climate change and marine ecosystems. The breathing out CO2 and how much there is really relevant to respiration and breathing. So many of those demonstrations can be used in biology class without doing anything at all.
Yeah, I like that. Actually, you remind me of, I had in 7th grade, a teacher named Mr. Zappala, and we called him Mr. Zap, because about once a week or sometimes more, he'd have something that would startle us, or, I remember he cracking water and making it go pop in the classroom. But he did that with biology stuff as well, because in 7th grade, you're doing sort of general science in the U.S., which was really cool. How are we feeling about the equipment? It's coming. Okay. It's booting up. Okay, that's cool. Yeah, no, I love that idea. And actually, one thing this gives me the opportunity to say also is, and I think Susan and I talk a lot about collaboration, is if you have ideas like that, I mentioned Bring Science Home, which is on scientificamerican.com, which has free activities, but we don't have special things for teens. And if there were some way, or students who are a little bit older, if there was some way for us to share things that you all think are really valuable, I would be happy to entertain that or consider it. And because I have not, I've run out of cards, I thought I should give everybody my email, and now seems like a good time as well. It's MDiChristina, MDiChristina, at SciAm.com, if you should ever want to reach out to me. Kate.
Yeah, it was occurring to me as we were talking, it's
Are you
the
set?
general theme across the 2 days has been a lot about how we can engage locally and how we engage young students and young people into the idea of science. There's a lot of us who come to this event every year. It would be nice next year to report back, maybe to ask everybody as a call to action, maybe to say, is there something you could do locally that you might want to report back on that might be new as an idea from this event or
Yeah.
other events that might stimulate some engagement, and we can hear from the community at large what we've done locally.
Yeah, Katie, I like that. Also, Dr. Gates's call to doing something about it at home, you know, in your community, at your home, seems like a great idea. So now, Kiara, do we feel good?
Yes.
Sorry about that. Thank you very much.
Yes.
And I will leave it to you, and thank you.
Okay. So thank you to Scientific American and Macmillan Learning for having me here today to talk about a bit more about my research and my innovation. So logically, before talking about myself, I wanted to ask the audience a few questions. And for the answer that you think is right, feel free to pick up your hand or shout out the answer. So now you get an understanding of how it is to be a student. How many of the world's 1-year-old children do you think have been vaccinated against some disease? 1-year-old children across the world. So A, 20% of 1-year-old children. Okay, so that's quite a lot of people. B, 50% of 1-year-old children. Okay, and C, 80% of 1-year-old children. There's not one, oh, there's one hand. And that, I'm not surprised about that. There's actually 80% of the world's 1-year-old children have had a vaccine. So I'm going to go into the answer a bit later and why people often don't realize it's 80%. But let's go on to question 2. In 1996, tigers, giant pandas, and black rhinos were all listed as endangered. How many of those species do you think today are more endangered? A, 2 of those species. Okay, we've got a few. B, 1 of those species or more. And C, none of those species. Okay, so and it is none of those species. None of those species are actually more critically endangered today. And so these statistics, we're talking about truth, they're from the United Nations website, and a book by Hans Rosling called Factfulness. So in my opinion, I think they're true, but obviously we've been talking about what truth is. But really why people often don't understand that the world is getting better is because we have a kind of an outlook where we all think that the world is bad. And that's because we don't give enough credit to innovations and ideas that are improving our world. Innovations such as better storage facilities and cooling methods for vaccines to remote areas. Innovations such as drone technology that help us protect our wildlife. That although the world is bad in many ways, is getting better. And that is because of innovations. As kids, we often look at the world that we can't really be optimistic, but we can, realizing that the world has made a lot of progress, and because of innovations, we can get to a place where it's not just bad but better, but just being our best. Now, when I was around 10 or 11 years old, I was always told that as humans, which is a scientific myth, but we use less than 1/10 of our brain power. Now, to a young person, that made me think that I couldn't really do anything amazing because we use such a small fraction of our brain power. How could I utilize that to do something amazing? Now, I know now that to do amazing things, you just have to use what you have, not a fraction more. And teaching kids that is really important. Now, often when I talk to children about innovation and STEM research, they say that they don't really have the tools to do really amazing things, to come up with world-changing ideas. And the truth is that in a simple smartphone, which most kids have access to, you don't have the same, but more computing power than those computers that were used in the Apollo moon landings. Now that is huge. Kids today have access to never-ending ideas, lists, research, and most of them just use it for Snapchat and Instagram. So when I was 13 years old, I was diagnosed with bilharzia, which is a parasite-induced disease, and a few months later with bacterial meningitis, which is quite literally the inflammation of the membrane surrounding the brain and spinal cord. So when I was in hospital, I remember thinking to myself, I was in grade 8 at the time, that if this is the strength of my brain to endure such immense pain, just imagine if this brain strength was used towards something still life-changing, but in a different context. And I call that inspiration. It's what really got me started into innovation and STEM research. When I left hospital, I knew that I couldn't just go back to doing projects, although STEM-based, but what I decided to do was invest every second that I had into understanding the answers to some of my questions, basic questions that I wasn't being given the answers to in class. Researching articles that I found in Scientific American, other Google articles. Now, I'm not quite sure if they were true or not, but, but I did that. I fed my curiosity, starting from a very young age. And after a while, I realized just by coming up with answers, it didn't really get me going anymore. What I wanted to do was create things, create innovations, and I had to start with a problem. When I started researching, I came across the issue of rhino poaching that the South African wilderness was experiencing at the time. And essentially what social media was showing as an answer was a permanent pink dye that was expensive, that had to be surgically injected in rhinos and had to be replaced every 2 weeks. Although it was getting a lot of exposure on Facebook, it didn't really seem like a viable solution to me. What I decided to do was on weekends, when I finished all my homework, was to invest my time into coming up with a solution that I thought was better. So what I came up with was a thermochromic dye that would only change color once the rhino was killed, essentially with enough advertisements and posters outside wilderness parks protect thousands of rhinos. It could be applied via drone technology, it's low cost, and it could be easily applied. I thought about that when I was 14 years old independently. My science teacher probably didn't know what I was doing, and probably my parents too. But what I realized was just feeding your own curiosity wasn't enough. I quite literally decided to feed other people with my next research project, which was the drought. South Africa was experiencing the worst ever drought since 1904. As a country, it only had 66% of rainfall since 2016. Now, when I was 15 years old, that was shocking. I knew that I couldn't do everything that I wanted to, but that was the main thing that I was going to tackle, the drought. So I came across something that were called super absorbent polymers, or SAPs. You can find them in a baby's nappy. And essentially, their SAPs are polymers or powders that retain large amounts of water relative to their own weight. Now, in theory, if you take a polymer and you apply it to the soil of a plant during a drought, when water does fall periodically, it would create a reservoir of water, allowing the plant to sustain life over a period of drought. So SAPs being used in agriculture were already available, but they were not low cost, they were not biodegradable, and they were full of harmful chemicals. We had a solution that wasn't solving the problem. So what I did was, with experimentation in my kitchen and my garage, or maybe my mom's kitchen and my mom's garage, I decided to research how I could find a low-cost and biodegradable SAP. It took me roughly over 2 years. And I didn't get it the first time. Neither did I get it the second time. It took me a lot of times to come up with a product that I believed was low cost and biodegradable, that used the polysaccharide found in orange peels, cross-linked via emulsion polymerization with the oils in avocado skins, that retained more water and kept soil more moist than agricultural SAPs. With the use of my SAP, drought security in drought areas could be increased by 73%. And I thought to myself, why didn't scientists think about this? How could one girl in just researching in her garage and kitchen come up with something that scientists didn't? And that speaks to the contribution young people have towards innovation and making worldwide impact. And I took this project and I entered into what is called the Google Science Fair, which is a competition that not only fosters diversity, but inspires curiosity in children. It doesn't expect them to come with a project. It allows them to develop a project in partnership with Google, to come up with ideas to make the world better. It really is a competition that encourages children to think out of the box, to realize that with their limited ideas and education, they can change the world and get a prize for it. So, teaching children that we should have an optimistic worldview, that our world can be our best with their contribution, and living by the words of Albert Einstein, when he says that the important thing is not to stop questioning, is vital to teach our children. Thank you.
Kiara, it's so great to see you again, and I just love hearing you talk about, this idea that everything starts with a question, and that kids are perfectly equipped to ask those questions and have the energy to pursue them. I'm just wondering, before I let other people ask you questions themselves, what are you doing these days to look for inspiration for the next questions you want to ask?
Well, I'm currently a freshman at Stanford, and I think just the availability of resources they have there to ask the bigger questions is really important. But I think right now I'm very involved in computer science, so asking those big questions. But I also think to teach children that the questions they ask is important. I always refer to the example that you can ask a question that leads you to Mars, which is a planet that really needs to be explored, or you can ask questions that lead you to Venus that doesn't really give you a basis of more exploration. So teaching kids that it's important to ask questions, but asking the right questions at the right time are just as important.
Thank you. I wonder if folks might like to ask Kiara something themselves. I see somebody in the front. Susan, you just gave your microphone away, so thank you, Nikki.
As you've gone around talking to, I'm assuming, other students or school districts or whatever with this message of inspiration for students, what are things, again, that this group, like, what should we do starting tomorrow? I mean, I am so inspired right now. I can't believe I'm still sitting in my seat. But, you know, this is your right, and we want to see more of this and support more of it. What are really practical ways that you think in your journey you were supported that we can take and implement?
I think as science teachers, especially, well, when I was in school, what a lot of the times science teachers think that kids want is to give them the tools to do it by themselves. Say, this is how you find an answer, this is how you ask your question, this is the process you go through, and this is kind of what you want to get to, the scientific method. But as a student that wants to do research, you kind of also have to give them the tools and springboards to the ideas of coming up with solutions. You can't just give them the process, the general process of following, and ask them to come up with ideas themselves. That means really teaching them or exposing them to the bigger problems that society is facing, like putting it in their faces. This is the drought, these are the issues. And Google Science Fair on their website, when I entered, had this amazing tool called an idea generator. So children could go onto it and fill in what their passions were, what they were looking to do in a science project, and it would give them problems and ideas to really tackle as basis of projects. And that is important because kids will only tackle something when they have an idea, like combating drought. But just to tell a kid all of a sudden to do an amazing thing is really difficult, even if they know the process. So giving them that initial idea, even if it is big, because kids can break things down, they can, with the research they have access to, just giving them the springboards of those big ideas on how to combat and make a worldwide impact. I think that's important.
Heather. Hi, I just want to say you're amazing. It's very inspirational. Now, I just wanted to know what, where did that go? You know, your research. Did science pick it up and move further to, you know, somehow make it a solution for drought?
Right. So I'm currently working with an agricultural company. Another thing that Google Science Fair has given me, it's given me the platform to be recognized by agricultural companies. So I'm working with them on research and development to get the product out there as soon as possible. I don't think it would have been realistic for me to do it by myself, especially you can't just, in the agricultural space, there's a lot of red tape. So I'm working in partnership with them to get it out as soon as possible and make the impact it needs.
Kiara, you mentioned the excellent point about the springboard for ideas. And just now you were talking about working with an agricultural company and so on. So an important thing seems to me to be, once you help the students with the springboard, or maybe some places they can start, supporting them along the way. If you had some advice to give to this group about how we could keep supporting kids along the way, or helping them even to support each other, what would those ideas be? I would love to hear them.
Well, when I was doing this project, I didn't tell my high school science teacher what I was doing. I was doing it by myself, so she had no idea of what I was doing. So a lot of my research was independent, which shows that you don't constantly have to be pushing children along. That idea for them to find solutions shouldn't always be something that you're constantly pushing in them, because it also has to be something that they have themselves. They should want to solve the biggest issues in the world. And I think instilling the fact that they can solve those biggest issues is really important, because once they understand that they can, I don't think as teachers you constantly have to push them all the time, but it is important to teach them a basic process of solving the issues, which is the scientific method, and how they can get a result of this worldwide impact, and not just introduce it as this broad idea that they also don't know the process. So I think there's a balance between giving them the understanding that they can, and this is how they can do it.
Yeah, we spent a bit of time yesterday talking about, letting students get actively involved, but also, how much do they need as a baseline,
Right.
how much practice does somebody need, or how many tables and things do you need to memorize?
Right.
And yeah, I think that's an important thing to work through. Does anybody have any last questions? There's one in the front. Thank you.
Hi, I'm Koshi Dhingra from TalkSTEM. So you're sort of, I think back to when I used to teach science, you're the student I would have loved to have in my classroom, and I would have loved to have you share about all this exciting stuff, because I would have wanted others in the class and school to be inspired by you. So my question is, how do we, which I think is the reason we're all here, how do we kind of, basically bottle it and build a network so that young people, maybe people who don't see themselves as STEM researchers, but perhaps they need different pathways to see themselves that way. And maybe the science classroom is not the best place for them because they don't really, it doesn't resonate with them. We're all human beings in different places, and people resonate with us. So how do we build a network in society, in a city, in a neighborhood, however, in your opinion, as a young person, that would be inviting to teens with a broad variety of interests and backgrounds to really participate? So basically I'm asking, how do we broaden STEM participation, cutting across boundaries like classrooms and museums, et cetera, because, who goes to science museums generally, although I love them, are generally people who are very interested. But how do we bring it to them in a wide variety of settings, and what would get kids to really want to participate in that?
I think just the acronym STEM is often something that puts kids off the idea of science, technology. It just sounds really like something they can't do. So I know when I was that age, I was probably the only one that was really excited about STEM. So I understand that a lot of kids don't go to museums anymore. They don't really do independent research. And I think creating groups in schools that foster these types of these connections and networks, and doing things like going into the Google Science Fair websites, reading about previous researchers, and it's got a great resource of the kids' backgrounds that are doing these things. Google Science Fair is so diverse that it's not just from one area of the world. There's kids from all across continents that are doing amazing research and exposing them to that. But there's also resources like TED Talks from various teen researchers that really show what their story is and how they came about to research, and playing things like TED Talks to these kids and really getting groups of kids together that want to do this and showing them that it is possible. And I think the best way to do that is to show them kids that have done it, role models. And I think with Google Science Fair, Intel, ICEF, there's so many science fairs and opportunities where they can find these role models. But also within the school, if there are science fairs, get the kids that have won in previous years the local science fair to come and speak about what their project is, so that they don't see that there's this child in another country that's come up with something amazing, but it's in their same school that has done something amazing. So getting groups together, giving them these resources and ideas, I would say is the best.
Thank you. I think we have time for one more. Yep. Great.
Hi, Elena Winslow from Chick Tech. I've asked other questions. So I think, we've talked a lot about inspiration, but what really struck me from your story was actually more about resilience. You said you were working for 2 years on your own, and I'm thinking about, what you said about, how can I as a kid, figure out this problem that other scientists haven't figured out. And so I'm wondering more about how it seems like you kind of supported yourself through that journey, which must have been difficult. It must have been intimidating to take on this big challenge, and then also to, take a long time to get to that eventual answer. So do you have advice more like for how children can self-coach, and then how, people who are working with children, either, mentors, teachers or parents, how we can help them through that part of the process?
I think probably something that I didn't talk about in the slides is how my parents assisted me. So I think that a lot of, it sometimes does come to luck that I was born with very supportive parents. So when I was 14 and I was spending every weekend in front of a computer or with science books, my parents encouraged me to do that. And when I told them stuff that I wanted to I wanted to research more into electromagnetism when it wasn't introduced in class yet, or I wanted to solve rhino poaching, and just really ideas like that. And those weren't the only ideas. I'd come up with a long list of ideas that my dad would say, no, rather leave that, that's pretty much not possible. But I was just getting ideas, and they would literally see what I was doing and say, that's good, you can do that. And I think that was pretty odd in a way, because most parents would be like, no, don't do that, rather focus on your work, because you're never going to solve the drought. I don't know what you're doing. But I think really letting kids do what they want to do when it comes to STEM research, and giving them the understanding that there's a boundary between, sometimes they're just not, they're wasting their time in certain aspects, and some that although it may be big, they can achieve it. So really understanding the balance between putting them in the right direction, but allowing them to still go towards big ideas. And I think a lot of children are always put down, whether it's with science teachers or with parents, that they can't do something and they should be investing their time into something more practical, but giving them the understanding that they can take that time and put it towards solving the drought, or finding a way to detect Ebola which was done by the previous Google Science Fair winner. So those types of things is really important from a parent and a teacher perspective, by encouraging that continuously.
I think that's a great point, Kiara, and probably a great place to end.
Thank you.
I mean, the idea of support, and then supporting resilience, giving people the direction, but then ultimately letting them kind of take off and go where they will. I thought that was really great. Can you join me in thanking Kiara for that great? You're getting your mic. Thank you. So it's to Susan and me to wrap up rather quickly. I mean,
that is a tough.
We've had quite an amazing arc, you know, of kind of, I would say, shared discovery in the past day and a half, and it was really a privilege to do that with everybody here. And we talked a lot about, I mean, some themes that came to me, you know, kind of over and over again, themes of collaboration, of kind of coming back to where your roots, your neighborhood, your home, your community, and then sharing outward,
growing from there.
Active exploration, you know, and in all the ways of good critical thinking and how important that is.
And optimism. I think we're normally pretty optimistic, and this past day and a half has been really interesting to see so much optimism, so much positivity out there, and it's really exciting and inspiring. And I hope everybody gets to leave with that, and stay on this track, that we can continue to do great work.
Yeah, I mean, I have
together.
to say, I was especially love the students this year. So Smitty yesterday said something that I loved, which is that there are great discoveries at the intersections of different disciplines. And I feel like exploring the edges is always going to be completely vital. And then where Kiara just left us here, just made me think, as I so often do, you know, when we look at the children of the world today, we are looking at the future and the path to it, and our role as both supporters, door openers, but then ultimately getting out of the way so they can do it is just such an important one. And I felt very hopeful and happy about that. So I like your
And
optimism,
a huge
Susan.
thank you to
Yeah.
the parents.
Yeah, and a huge
I mean, this
thank
is,
you.
You have some amazing kids.
Your kids are amazing.
That
Thank
is
you
not
for
by
sharing them.
accident. So, yeah, thanks for bringing them. So I think as we wrap up,
Yeah. Add a close.
thank you everybody for coming to another. For those that this is your first time, we look forward to seeing you at another one. Please do fill out surveys, information, everything that's sent to you so that we
Get
can
into the
start
app.
planning, because there is a very short break between these. Would love to hear from you in any way, any comments possible. Nikki, do we have any last?
Stick around for lunch.
Stick around
All
lunch,
right.
do libraries, safe travels
Yeah, check
home,
out the
everyone.
library. Enjoy Austin. Thanks again.